ahead and let's go ahead and get started. Now I can call them stragglers, right? The stragglers, a couple more minutes, hopefully, to show up. I know that first test wasn't spectacular, but hopefully we're not down to this small of a number of students already. So let's talk game plan. There's a lot to cover today before we get started. So let's go over this. We have short turnaround till the next exam. The next exam is the 18th. And a fair amount of material to cover between now and then. So we're going to start that today and pound through it through the next 3 lectures to get you ready for that exam. Today we'll start our discussion of tissues and also talk about histology. I'd love to tell you after that first exam that things get better, but they don't. I think this next section is the least intuitive, making it the least challenging. I mean, the most challenging because it's the least intuitive. A lot of people can struggle because a lot of people know the brachial region or the cranial region or things along those lines, but not as many people are as familiar with the histology stuff. And unlike a lot of things, there aren't a lot of shortcuts to it. So it's going to take a lot of time and effort to be successful in this. And we'll do the best we can to help you to prepare for that. We have a handful of assignments to help you to do that as well. Your Unit 5 review, your Unit 6 review. There's a skin color handout. There's a video you watch and fill out the handout for that, and you're going to turn in. There is a fingerprint activity that is based on the information that is in your lab manual. There's a chart in your lab manual. Obviously, we're not in the classroom, so we can't quite do that activity, but it is something you can easily do at home. It's something you can do with your kids if you have kids. It's a very fun activity. So that is due on Tuesday, the 16th next week. The other thing that you're going to be turning in is your study guide, your histology study guide. I've given you a histology study guide because, as I said, when we get to things where I'm distilling the information more, I will give you a study guide for the lab exams. And to help you to prepare for that lab exam, you are going to be completing that. And so today in lab, we'll talk about what you are going to be responsible for on that and how you're going to do that. And that is going to be turned in. I really tried hard to get the exams graded for today so that I could return them to you today. I have gotten all the lab exams graded, but I haven't input them and I haven't figured out the curve yet. And I'm over halfway through the lecture exams, but I have not had a chance to finish them. But I do still want to take this opportunity to talk about them, even though you haven't gotten them back yet. How to say this nicely. The exam scores are, from what I've seen so far, the first exam always has a wide range of scores associated with them. Some people come in really prepared. Other people don't fully appreciate this is their first real science class. And so there is a wide range of scores. But for my part, there were a lot of things that were things that should have been easy fixes that I've warned you about numerous times, and yet still were traps that people fell into. One of the things that you need to really, and so here's the good news. Let's start with this first. Nobody's grade in this class has been determined after this first exam. Mathematically, every single person in this class can still get an A, right? If someone totally aced this first exam, they can't just sit back and rest on their laurels for the rest of the semester. They can just take on faith that they studied the first part successfully. Yeah, hold on 1 second. I'll get to that, Arthur. To get to this successfully, but they have to keep doing what they're doing. And if you weren't successful on this first exam, then don't go to the bathroom and flog yourself with a whip. Just know that you need to dramatically change the way you're attacking this material to help you to be successful. Mathematically, it is still possible to get an A in this class, but you have to improve your grades on the exams quickly, especially with the next exam basically 2 weeks away. So that is going to take some work, and we will talk about that a little bit. Yes, as I said, the tests are curved. So like I said, I've graded the lab exams, but I haven't figured out what the curve for it is yet because I haven't put it into my official grade book. So all the exams are curved. Yes, I will be curving the exams. So yes, it helps, but I'll be honest, from what I've seen of the raw data, it's not going to help a lot. The information is bad. The grades are not good. No, there's not an attendance quiz or a 5 for 5 quiz today. Again, there's no more attendance quizzes. Attendance quizzes are done. Attendance is set. You're either here or you're not at this point. But there is a daily quiz. I don't remember. I don't I don't think anybody got 100 on the lab, but I don't know about the lecture, but I haven't curved them yet. So we'll see how that works out. Those numbers are important. All right, let's talk about the things that you can do to improve. One of the biggest things that you need to do is to avoid simple mistakes. Oops, that's not right. Try that again. Avoid simple mistakes. Despite the things that I said numerous times, a ton of people didn't put left or right. As a grader, there is nothing more frustrating than someone remembering that this is the acranial region, but forgetting to say that it's the right acranial region. There's nothing more frustrating than having to cut your grade in half when you got the hard part and you forgot the easy part of something like that. On the essay questions, make sure you answer all parts of the question. Often questions have 2 or 3 parts, and I have plenty of people who did a great job describing the first part and didn't address the second part of the question. Right? So make sure you answer all of those questions and make sure you read the questions carefully. There were plenty of examples of individuals who lost points because the arrow pointed at the pancreas and they said pancreas, but the question was identify the function of this organ. Or it was pointing at the Golgi apparatus, and you told me it was the Golgi apparatus, but it asked for the function of that organelle. Or I asked for an organelle and you gave me the structure, or I asked for the structure and you gave me the organelle. Vocabulary is important. I'm very precise in the writing of my questions. You need to be equally precise in answering them. And a lot of people gave away points. I lost count of the number of people who lost at least 3 points because the half a point here, half a point here, half a point here, because they didn't use left and right. You got to make sure you watch out for those types of things. Those are very simple ways that people lose points that are very easy to fix. And adding 3, 4, 5 points back into your score can make a huge difference. So make sure you're watching out for that. Now, like I said, I tried to get the grades posted. I didn't finish the grading. I'm hoping to get the grading finished by maybe tonight, but if not tonight, probably early tomorrow. So what I will do is that at that point, I will then post the grades. After I post the grades, then basically on Thursday, I will release the grades. Let me say this. I will release the exams for review. Exams are a learning process, and you should be able to review your exams to be able to see what you got, wrong. I will release them for 24 hours. So that means on Friday, they will be locked again, at which point, if you have any questions or concerns, you will need to come to my office hours and we can then review your exam together that way. So it will only be available for 24 hours. So during that time, make sure you review your exam and ask questions. If you're not clear why you got the grade that you got on a particular question or why something was marked wrong or partial credit or something like that, do that and do that first. Don't wait a week, 2 weeks, a month before you give me that information. All right? Questions on that? Stunned silences. You guys can't hear me, right? My mic's on?
Yeah.
Yes,
When
we can hear you.
when you put the key out,
I don't post the key.
oh, when you put the
I release the exams so that you can see your exams, the answers that you put in.
Okay, yeah. When you do that, are we still able to see you during office hours if we have questions?
So
Until it's locked again?
Yes and no. So yes, the best thing to do is to email me about those questions, and then I will make arrangements to talk with you. Okay?
Okay.
I'll explain my hesitation in just a minute. All right. Any other questions on the procedure of this? Like I said, the numbers, as I've looked at just from the raw data, are not particularly good. So some people really struggled, but as I mentioned, this is a learning experience. Use this first exam to understand what I'm expecting from you and use it to learn from so that you can be more successful moving forward.
No one got a complete 0 though, right?
No.
Okay, you hesitated on that. I was like, whoa.
Well, thank God.
Well, but okay, well, that brings me to the last thing that I would say as well. Another simple mistake is leaving questions blank. I unfortunately did have students who left a lot of essay questions blank, right? And again, I know essay questions can be a bit intimidating, but one of the important things to remember about essay questions, the magic of essay questions, is partial credit. Right? The problem with a multiple choice question is you could completely have mastered that concept of a multiple choice question. Heck, your uncle could have been the one who discovered it. You could have had your picture taken with that concept. But if you misread one word in that multiple choice question, you misinterpret the question and they've got that trap answer to get you, and you don't get any points for that. Yes, with an essay question, if you know all the points, you get, if you get all the information, you get all the points. But even if you know some of the information, you are going to get some of the points, right? Don't leave questions blank, right? And that's true for the lab exam as well. I've talked to students before. I see your hand, Madison. Give me a second. I've talked to students before about why they tend to leave things blank, and they do it because they don't want to look stupid. Right. That's again, I don't think you're stupid if you leave it blank, but that is what I've had, or if you write the wrong information, that's what I've had students say to me. My response to that would be nothing looks worse than leaving it blank. At least try to say something, try to write something, throw something at the wall and see if something sticks to even get a couple points. Because a couple points, especially on the lab and lecture exam, which is standardized to 100 points, can make a big, big difference. Go ahead, Madison.
So on the lab exam, I know you had to like redo it in a way that like you had to upload a picture per page. That worked for me. I don't know if anybody else had that issue because like it took me about probably 45 minutes just to get into the exam, and then it took too long to where Canvas had logged me out. Yeah.
No, thank you so much for bringing that up again, because I had actually forgotten about that. I railed on that in my 431 class yesterday because their exam is tomorrow. In the history of us being online, we've been online for a year now. We transitioned online last year. And so we had the end of spring, we had summer, we had fall. This is the very first time that I have had an exam that was this bad. Literally a third of you had problems logging in and where you couldn't get it to load. Now, here are the things that I would say about this. In looking at the data, because I finally got a chance to look at the data, for most, not all, but for most of the people that had problems loading it, there were two main issues that I saw people had. They either had poor internet connection, and again, it doesn't necessarily mean that it's bad in your house, but maybe the location of where your computer was. But the other issue that I saw is that a lot of people did not have the working available RAM or the space on their computer for that. I know Proctorio recommends 2 gigabytes, and a lot of people were taking it with 0.6 or 0.4 gigabytes of RAM available. So one of the things that might help is if you close everything else out, close all the other things that normally are running, that might be something that helps. I am hoping it was more of an issue on their end, something between Canvas and Proctorio. But Proctorio claims it wasn't them, that it was something Canvas related. And yes, I don't prefer the format of one question at a time. If we have to do that, then I will do that. And I'll have a better idea actually tomorrow, because tomorrow my 431 class gets to be the guinea pig to see if this happens again, because it has never happened before. And that was one of the smaller lab exams. So I'm going to see what happens tomorrow. And if I start having problems the same way tomorrow, then I will do that. It's not a bad way to do it, to go through it that way. And the one nice thing about it is up in the upper right-hand corner, you have the list of all the questions. So if you skip a question, you've got the 0 there to show you, or the circle there to show you that you didn't answer it. And so if you're at question 42 and you realize you want to double check something on 12, you don't have to hit back 15 times to get back there. You can just click question 12 to go back there. I don't mind the format. I prefer to have it all on the same page because it takes less time. But if it doesn't work tomorrow, then I will be switching to that format. And I'll add a little bit more time and I'll switch to that format. But I absolutely positively do not want to have what happened the last time happen. Now, the one last thing that I will say about this, and Dimitro, give me a second. I have to see your hand as well. The one thing that I want to thank most of you for is that when you had those problems, you reached out to me immediately. To let me know that you guys had those problems, and so that we were able to work with it and I was able to accommodate everybody. Unfortunately, there were a couple people who waited a day or two before contacting me about the issues. And at that point, 2 days after the exam, a day after the exam, I'm unfortunately not able to accommodate you. I tried to send the announcements, I sent out the emails, I tried to make people aware. And if you're having those problems, you need to contact me immediately. I'm hoping that tomorrow's exam will help to see what we need to do to be successful, but I will change things that way. No, go ahead, Dimitro. You had a question?
Yeah, real quickly, I wasn't sure if I was the only one, but you mentioned about the questions being on the right-hand side. When I skipped the question and I tried going back, it said that I risked exiting out of my exam, so I just left it blank. I don't know, maybe if I was the only one, but when you made it, it was still way better than the first attempt that I had, where I just sat there and kept getting kicked out. But for example, I skipped question 2 and I moved on to 3, and I thought, oh, maybe I can go back to question 2. Now I think that I remember it, and it said if you risk leaving the exam, and I was like, oh, whatever, I just left it. So I just made sure that I wouldn't, go back.
Are you sure you weren't clicking outside of the window instead of on the
No.
question?
I was definitely clicking on question, whatever I needed to get back to, and I was like, okay, well, whatever.
Okay, well, the only thing that I would say is my understanding, was anybody successfully able to use that to go back to questions? Madison looks like
I
you
had that on mine, and I was scared that I was going to get kicked out. So I waited until I was done with all the questions, and I just risked it, and it let me go through them. But I thought it was going to kick me out too.
Okay, well, so the only thing that I would say to that is that, remember, if it does kick you out, you can get back in if we do that format. But it looks like that might not be a bad way to do it. Wait till the very end and then go back. But
I did try it and it did work. Like I took the risk and was like, I'm going to click them, and they totally work and go back and let you go back.
It is supposed to work and allow you to go back that way. So I apologize for the warning. Again, this is brand new. I've had students in the past that have had issues. Madison actually was one of them who's had issues in the past, but I have never seen anything like what happened on Thursday. So that was incredibly frustrating for me, and I got to imagine it was incredibly frustrating for you. So I do apologize for that.
Yeah, Professor, you really scared me. I reached out to you and you're like, I'm sorry, Dimitro, I can't help you because this is supposed to be done by proctorio. I was like, oh no.
Well, because normally these are issues, I cannot physically put a student back into the exam. So for those of you who are not aware of it, for the students who did have problems, the one thing I can do is end their current test and make a second test available for them so that they would be able to take it. But it'd be a brand new test with brand new questions, so they wouldn't be there. Someone else, I don't remember exactly who it was, also had a problem that I've never seen before, where they got all the images, but they didn't have the spaces where you fill in and write the answer.
That was me.
Yeah. So again, that problem I've never even heard of before. I asked some of the other instructors. Nobody's seen that before. So I don't know what that was.
I reloaded it 5 times and it gives me all the images. I'm looking at the questions. At one point, I went and grabbed an empty piece of paper and I showed it to the camera.
Which I saw and I did not like. Don't do that.
I was like, Professor,
I
am completely clueless on what to do. Here's an empty sheet of paper.
I did see that and I appreciate that. No, I understand, but no, you handled it the right way by contacting me. Madison, was there something else that, and like I said, I'm hoping tomorrow will help to resolve. And if we have to do it with more time and one question at a time, everybody who I set up that way was able to complete it that way. So I at least I know that will work. So it's not my preferred method, but I know it'll work.
Yeah, I mean too, like, so when it took me probably about 45 minutes to just like get loaded and logged out. And at one point I got so frustrated, I just contacted Proctorio just to exit me out of the exam so that I could contact you.
Yeah.
And then after that, that's when my husband got involved and started doing all these weird things with the computer.
So yeah, so the only thing, I'm not blaming anybody, and it wasn't consistent across everybody. But the one thing that I would say is that consistent for most, not everybody, but for many people. They were short on the RAM and they were short on the internet connection was not good. So those are things that can influence it and affect it as well.
Yeah, I mean, it's just interesting because the computer that I am on is a gaming computer, so it has a high enough capacity of RAM, and I'm hardwired into the.
So it shouldn't be an issue. Yeah, and again,
yeah, so that's where it got kind of weird.
Yeah.
But I'm wondering with Dimitri, like how his images uploaded, but he couldn't answer the questions. So I'm wondering, yeah, that.
I'm hoping it was on their end, and I'm hoping it won't be an issue.
I think it probably was.
We'll find out more tomorrow, so we'll see what happens tomorrow.
Fingers.
All right. Thank you for bringing that up. I've written all these other things that I had totally forgotten about that. So, any other questions on that? All right. I'm going to pause the recording. Ready. Excellent. So let's move on to the second part of our class. And this is going to be the tissues, and our very first organ system. We'll finally get to the integumentary system. Of all of 430, again, I'm not randomly picking the things we're learning out of a hat for 430. There's a lot of stuff that we're going to use again and again and again throughout 430 and 431. Obviously, the directional and regional terms are something that are going to be used throughout. Our autonomic nervous system, which we're saving for last, is probably some of the most important stuff we'll be using when we move to 430. But probably the most important thing moving forward is this one right here, talking about the tissues. Because as we talk about every organ and organ system is made up of tissues. And so we have to talk about those. Now, there are 4 types of tissues found in the body. Someone name one for me. What is it? Type? Connective tissue. Excellent.
Nervous tissue.
Perfect.
Muscle tissue.
Muscle. I heard nervous. I heard connective.
Epithelial.
There you go. Epithelial and connective. All right, perfect. You guys said connective first. What do connective tissues do?
It connects.
There you go. They connect. I love that. Excellent. The building is tall because it is tall. Yeah, absolutely. Connective tissues, among other things, bind things together. However, one of the interesting things about connective tissues are the most diverse in structure. And if they're most diverse in structure, they're also going to be most diverse in function as well. So while they bind things together, they also offer things like protection, right? In the form of your skull or in the form of your white blood cells, right? They store energy. Helps if I spell energy right. And so on and so forth. Transportation, there's lots and lots of functions for connective tissues. They're very, very diverse. This is pretty different from epithelial tissues. Epithelial tissues, right, are what? What do they do? Anyone know what our epithelial tissues do?
Cover the surfaces.
Excellent, I love that. Line the surfaces of the body. And that is both internal and external. So they also provide protection. They form boundaries. But do they produce impenetrable boundaries? No, they are going to allow movement into and outside of structures. So they play an important role in secretion and absorption. Epithelial tissues are also used to make glands. What about muscle tissue? Muscle tissue is a very specialized tissue. What is it specialized for?
Support.
Say again?
That support the body.
True. One of the functions of it is absolutely to provide support.
Movement.
Right, and movement.
And structure.
And structure. Yep. Absolutely. However, muscle's kind of a one-trick pony. How does muscle do all of this? Muscle is specialized to do what?
Attached to the bone?
Well, they do attach to the bone. And what do they do when they're attached to the bone?
Movement of blood.
Okay, but what is it that actually causes that movement? What does the muscle tissue actually do? What's the magic word?
Does it communicate
Contraction.
with the brain?
That's what I was looking for, contraction. It's specialized for contraction, right? And that contraction is what does all the things. It supports your organs, provides structure, produces movement through space, right? Propelling substances through our body, generating heat when we're cold, right? Muscle's pretty much a one-trick pony, specialized for contraction. Nervous tissue is also a one-trick pony. What is it specialized for?
Communication.
And how does nervous tissue communicate?
Through neurons.
Well, the neurons are the cells, but what do the cells produce that they use for communication?
Action potential.
Yeah, absolutely, through an action potential. What is an action potential?
It's negative energy moving through your body or something like that.
You've got the right idea. It isn't so much negative, it's actually the opposite, it's positive, but you got the right idea. It's actually a big positive electrical signal. So basically it produces this big positive electrical signal that we give a fancy name to called the action potential. And it's used for communication with the parts of our body. Now, there's one more thing I think we've known about muscle tissue is that it comes in 3 flavors.
Skeletal, smooth, and cardiac.
There you go. Skeletal, cardiac, and smooth. Excellent. So there you go. There are our 4 tissue types: epithelial tissues, connective tissues, muscle tissues, and nervous tissues. Now, muscle tissue is highly specialized. And so we're going to focus on it when we get to the muscular system. We need to know it's specialized for contraction. It provides movement and structure and support. There are 3 main types, but that's pretty much all we need to know about it for now. Nervous tissue is also highly specialized. We know that it is specialized for communication, able to produce that big positive electrical signal called an action potential. But again, we're going to focus on our study of nervous tissue when we get to the nervous system. What that means is, if on an exam, I ask you to identify and describe the tissue types of the body, there are definitely 4, and you would need to list them all 4. And again, anytime there's a list or a process, that's definitely something that would be a good essay question. However, our primary focus for this exam is going to be epithelial tissues and connective tissues. So that is what we're going to primarily focus on for now. So again, we have our epithelial tissues covering the surfaces, line both the internal and external portions of our body, and they form the ducts and our glands. Connective tissues support, protect, bind, store energy, transport, provide immunity. Again, these are our most diverse, both in structure and in function. And again, we talked about muscle tissue and nervous tissue. So here's a pretty picture that shows some examples of where some of these things are located of our 4 tissue types. And before we can actually make tissues, we need to go back a little bit and talk a little bit more about cells. Tissues are made up of cells, and those cells are not just randomly put together. So when we put them together, we often put them together with structures called cell junctions. This information is actually back in chapter 3, but we weren't responsible for it on that exam. Instead, we're going to save it for this exam when we talk about it here. And as you can see here, there are basically 3 main types of cell junctions used to hold cells together into tissues. Now, do all tissues have all 3 of these types?
No.
No. And here I think would be the best way to say this. Most tissues have one or more of these cell junctions types. So most tissues have one or more of these. That's going to mean some tissues are going to have two, some tissues are going to have three. It also means some tissues are not going to have any of these, 0 of these, right? So again, not every tissue has cell junctions, but many of them do. So let's take a look at some of these cell junctions. And I'm going to actually do this for me first. Let's do this as a drawing, and we'll bounce back and forth from the pretty pictures in your textbook to the pretty pictures that I draw. First thing we need to do is make 2 cells. So let's do that. Here is cell 1. Here is cell 2. The first type of cell junction is what is known as a tight, or it is also known as an occluding junction. In this type of junction, and actually let's see if I can do it this way. It uses these globular transmembrane proteins. So I think I need to make that a teeny bit smaller. There we go. So what happens is that there is a globular transmembrane protein. Remember, transmembrane protein is a protein that goes through both layers of our phospholipid bilayer, both inside and outside. And the same thing happens, and I'm going to cheat, grab it and move it, on the other side as well. So we have these interlocking proteins, one from each side, from each cell. If you haven't figured out by now, I like my analogies. And I've got 2 good ones for this. The one that I think of first is like a zipper. If you think of a zipper, you have these individual keys from the 2 sides. And what happens is those keys interlock with each other. And when they interlock with each other, they hold the 2 sides of the jacket together. And that's essentially what's happening here. The other example, and let's go back to the pretty picture from your textbook to see this. The other example that I think of when I look of this is I think of my grandmother. My grandmother was part of a quilting club where her and 6 of her closest friends would all get together on this big patio, on this big porch outside, and they'd all sit around this big quilt, and they'd all take a different corner of that quilt, and they would do these massive, elaborate quilting designs within it, where they basically use a needle and thread with some batting in between 2 pieces of sheet and knit together these elaborately very decorative designs. And you notice with these tight occluding junctions, both plasma membranes are held together by long lines of these interlocking proteins. Now, obviously, one of the major advantages of these is that it holds the 2 cells very tightly to each other, which is why it's called a tight occluding junction. In fact, so tightly that essentially it produces a waterproof seal. So that, and let's go back to the picture of my picture for this. Things that are in the water outside here, outside the cell, can't easily pass between the cells to get out the other side. So it helps to form a waterproof barrier. Where might this type of tight or occluding junction be useful? Where might we want to have, sorry, say again?
The bladder.
Bladder, absolutely, right? What does your bladder contain?
Urine.
Urine. And none of that is stuff that you want. That was all waste material that has been released from your body. So we don't want that stuff getting back in. So having that bladder lined with a bunch of tight junctions helps to keep the water in there until we can void it from our body. Give me at least one more good location.
Stomach.
Stomach, digestive system. We want to control what gets into our body from the food and the drink that we ingest. Those are excellent. Those weren't even the ones I was thinking of. What's another really good example of a location where we want to limit the movement of water into and out of a barrier? Skin, right? Excellent. How many people have ever washed the dishes before?
Yep.
A couple of you. Excellent. Right? Now, with that, when you take that kitchen sponge and you put it in the water of the sink, what happens?
Soaks it.
It soaks it up and it swells dramatically, right? How many people here have taken a bath before? Excellent. At least 2. Excellent. The rest of you, I highly recommend it. Right? When you jumped into that bathtub, did you swell up like that sponge from sucking up all that water where the level suddenly went down 4 inches and you blew up like a balloon?
No,
No, of course not, because our skin is a mostly waterproof barrier. Absolutely. So absolutely. Those are the types of places where we want a waterproof boundary to be able to do that. So that is something that is very, very useful. All right. So again, we'll come back to the pretty picture here. So like the bladder, like the digestive tract, things along those lines. Exactly. With 2020, everyone should be taking baths. All right. Notice this second type of junction is what is known as a desmosome. Your book actually does a really nice job of showing this, but it's a little bit more elaborate. So let's talk about a desmosome and let's draw it again first. So again, we're going to put 2 cells here. Oops, no, let's stick with black. Cell 1, cell 2. Notice with this desmosome, there are a lot more components to it. The first of those components is basically a thick peripheral protein known as a plaque. So here we have this very thick protein. It is a peripheral protein, which remember means that it is associated with the plasma membrane, but not exactly connected to it. So it doesn't connect directly to the plasma membrane, but it is right up against it and it is associated with it. So it is a peripheral protein. With that peripheral protein, we then have these structures. How am I going to draw this? Let's do it this way. Transmembrane proteins that are embedded within the plaque and extend outside of the cell. And they occur on both sides. Now, there are several of these types of transmembrane proteins. But the most common of these is one known as cadherin. What does it mean to adhere?
To stick to things.
To stick. These are proteins that become sticky, but they only become sticky when something is present. And when it's called cadherin, what do you think that special thing, that thing that makes it do something wonky like being sticky, might be?
Calcium.
Calcium, exactly. In the presence of calcium, which is always in the interstitial fluid, these cadherins are sticky and they stick to each other. But that's not all we're relying on to keep these things together. On top of that, we have our structural I-beams. Remember, we talked about those intermediate filaments. Intermediate filaments are those proteins of the cytoskeleton that play an important role of giving a cell its shape and its structure. And again, your book does a great job of showing this, but it doesn't even show the coolest thing that these cadherins do. Some of these cadherins will actually cross from one cell into the other. Notice with these massive amounts of proteins, we form this very tight, very strong bind between these two cells. Now, think about it. If you have two big, huge, massive plates of metal that you want to attach to each other, do you melt the entire surface of one of these so that it attaches to the entire surface of the other one?
No.
No.
No. Typically, you'll do just 4 or 5 or 6 or 10 small little, what they call spot welds. And those spot welds basically form a really tight connection between those two pieces of metal. And that's exactly what this desmosome is. This desmosome is basically a cellular spot weld that holds these two cells together really, really tightly. Where might something like this be useful? Where do we need cells held together really tightly?
Skin.
Skin, right? All that abrasion, rubbing your arm, rubbing your skin, right? We want to be able to hold it together, not have it peel off.
Muscles.
How about the muscles, and in particular, cardiac muscle? Your heart. Your heart is producing a massive amount of pressure to pump the blood through our body. And so to be able to produce all that pressure without tearing the cells apart, we have these tight, spot weld desmosomes that hold it together. So again, let's look at the pretty picture from your textbook, and we can see these things. We have here, there is a yellow, these dense peripheral proteins that are the plaques. They're the attachment point for our transmembrane proteins like cadherins. And here we see them attaching to each other. Here, going through and attaching to each other. And then here we see the intermediate filaments coming in and anchoring it together as well. And like I said, the one thing this doesn't show is that some of these intermediate filaments will go from one cell actually over to the next. All right. And so, like I said, skin, cardiac muscle, great example of places where we might want this. All righty, that leaves us with our third type of cell junction known as a gap junction. Notice what's going on here. And again, let's go back and draw this first. Cell 1. Cell 2. In this case, and I'm going to totally cheat here. Put that there. Perfect. What happens with this one here there are these proteins, transmembrane proteins that are embedded within the wall of the plasma membrane. What's going on? There we go. And pretend they're the same size. And the things are in both cells. And these proteins are called connexons. So here we see 4 connexons. Working together. But as we saw from the previous picture, they basically form a fluid-filled channel. Between the cells. What this allows for is the rapid movement of materials back and forth from one cell to the next. Now, is this necessarily doing a good job of holding these two cells together?
No.
No. So then what is its function?
Transport things between cells.
Yeah, it allows for the rapid transportation of material between the two cells. So whatever happens in cell A is going to be able to rapidly spread and affect cell B. It's kind of the opposite of filtering. Can it really filter? I mean, anything that happens, any changes, if there's a massive increase in sodium in this first cell, that sodium is going to rush to the other cell. So in fact, it's the opposite. It's like hardwiring these two cells together. Basically, these two cells are essentially going to function as one. So it allows for rapid communication, allowing these two cells to work together quickly as one. Where might something like that be useful?
Nervous system.
Okay, but we got to be careful with the nervous system. You are correct. We will find some of these in the nervous system. But remember, nervous system is like wiring, like the wiring in your wall, which is really, really convenient because when I flip the light switch in my room, the light goes on. And when I flip it again, it goes off. And when I flip it again, it goes on. And when I flip it again, it goes off. And if I sat here and flipped it 100 times, would any of those 100 times something different happen? Is the front door going to open? The garage door go off? My kids listen, right? Is anything going to happen differently when I flip that switch other than the light going on and off?
No.
No, right? And yes, there is advantage to being hardwired like that, but we don't necessarily want our nervous system to be hardwired because while I sit here staring at you through a camera, holding my red pen in my hand, and I look you in the eyes and I say, I'm going to kill you. And a bear with an axe walks into your room, looks you in the eye and says, I'm going to kill you. Are you going to respond the same way to me as to that bear with an axe? No, you're getting the exact same input from both of us, but you're going to respond very, very differently. So 100%, there are locations in our nervous system where we use this, but not nearly as many as you would think. Because the advantage of our nervous system is we want to be able to make decisions. We want to be able to modify our behavior, right? Yeah, whether you're from Russia or not, there is nothing scarier than a bear with an axe. Bear with an axe, bear scary, axe scary, bear with axe, super scary. Especially because they don't have opposable thumbs. Truly, truly terrifying. All right, so nervous system, yes, but not as much as you would think. Where's a system? What's an organ that we do want it working together as one efficient, or let's even say one efficient, cohesive pump?
Your heart, not
Heart.
sword.
Absolutely. The heart. Stomach is another great example. Absolutely. So there's muscle tissue like the heart. There are some nervous cells that are going to be that way, but not quite as much. Okay, moose may be scarier than a bear, but we all know mooses can't carry axes because they have hoofs. So again, there you go. Doesn't work. No, look, studies have been done. There is nothing scarier than a bear with an axe. All right, excellent. So now we know how to put cells together to make tissues. So now that we've put cells together to make tissues, let's talk about the first type of tissues that we need to talk about, and that is going to be epithelial tissues. And actually, you know what? We have got so much to talk about today. I know we didn't get as far in lecture as we wanted to, but we had a lot of other stuff we needed to talk about. It is a teeny bit early, but let's go ahead and take our first break here. Let's go ahead and take our first break here. We'll make it a 15-minute break, come back at 1:10, and at 1:10, we will restart the lecture at that point. All right, and I will start the recording. So any questions on our cell junctions before we take our break?
No.
All right, I will see you guys in 15 minutes then. Let's go ahead and get started. All right. Our goal now is to talk about characteristics of all epithelial tissues. There are some characteristics that all epithelial tissues share. We will talk about individual epithelial tissues, their characteristics, and things along those lines, but there are certain characteristics that all epithelial tissues share. One of them, and probably one of the most important ones, is that they are very cell dense. Because of this being cell dense, again, they're lining surfaces. They need to be able to form a barrier, and they do that by having lots of cells. That also means there's not a lot of room for other stuff. Now, the good news is when identifying them, we can then identify them by these cells and their layers. So let's clear this and start talking some rules. So again, these are characteristics of all epithelial tissues. As we already talked about, they are superficial, right? And they line surfaces, but they are also very cell dense. So when determining this the epithelial tissue, when identifying them, basically there are two categories that we use, two characteristics to identify. The first is the shape of the cell. And as we'll talk about in a second here, there are three different shapes that cells can have. And the second way we identify them is by the number of layers. Now, let's start with the number of layers first, because it's easy. If an epithelial tissue is comprised of one layer of cells, then we call it simple. If it is made of two or more of cells, then we call it stratified. There you go. Simple rule, easy breezy, lemon squeezy. Let's talk about the shapes then. As I mentioned, there are three shapes. The first shape is basically, I think I can cheat and do it this way, a broad, flat cell, kind of like a tile. And that broad, flat cell style is what we call squamous. These cells are so flat that often the nucleus of them actually bulges out bigger than the size of the cell itself. So these are big, huge, massive nuclei and these super flat cells that we have. The second are basically short block-shaped cells. And these short block-shaped cells we call cuboidal. Right, these are the block cube-shaped cells, so we just have a big block shell. And the third shape are tall, thin, narrow cells. And these tall, thin, narrow cells are known as columnar, like big columns. Right. So using these, you take them together and you can come up with a type of epithelial tissue. If you had an epithelial tissue, which was made up of a single layer of very tall, narrow cells, what type of epithelial tissue would you have there? And I could continue this, but I'm not going to. What would that be?
Columnar.
Simple columnar. There you go. See? Simple columnar. If we had a tissue that was made up of two layers of block-shaped cells, what would you have there?
Stratified Cuboidal.
Yeah, stratified cuboidal. There you go. Just that simple. Now, as we've learned in anatomy and physiology, is anything truly just that simple?
Nope.
No, because anatomists hate you and they will change the rules on you. But it's a good starting point. So there you go. We identify our epithelial tissues basically by the shape of the cells and the number of layers. All right, questions on that? Now, another important characteristic of our epithelial tissues is that our epithelial tissues are polar tissues. Now, up to this point in time, when we've used the term polar, what were we talking about?
The charge, like
the charge. Things are positive and negative, typically when we think of things that are polar, right? But polar also can mean something else, right? A magnet is polar because they're the two different ends, while they look the same, have different functions. If you take a magnet and rotate it 180 degrees the other way, is it going to function the same way? Or let's take an even simpler example, right? Being an anatomy and physiology instructor, I am constantly stopped on the street and asked for autographs, which is why I always keep my red pen around. Does it matter which way I point my red pen towards the paper when I write?
Yeah.
Yeah, absolutely, because one side is different from the other. And so when we talk about epithelial tissues are polar. If we were to take an epithelial tissue and flip it upside down, it's not going to function the same way. Epithelial tissues have different sides. And if it has different sides, we're going to have names for those sides. All right. Here I have an epithelial tissue, and even though we already did this one, I'll do it again. Single layer of tall, narrow cells. What type of tissue is this?
Columnar.
Simple columnar, excellent. Oops. And simple columnar epithelial tissue, or epithelium. Epithelium is the noun. Epithelial tissue is the adjective that describes the noun, tissue being the noun, fun with vocabulary. And of course, the plural would be epithelia, right? Fun with vocabulary and spelling. But here we have a simple columnar epithelial tissue. It has a top and a bottom. Of course, we're not going to use terms like top and bottom when identifying them. So instead, we refer to the top of the tissue as the apical surface. Now, remember, epithelial tissues are superficial. So what is above the apical surface of a cell, of a tissue? Well, let's think of it this way. Do I have an epithelial tissue here on the surface of my hand?
No.
Yes, because it lines the surface. So this here is an epithelial tissue that you're looking at here. And what's above it?
Hair.
Well, okay, true. But I shaved my hand. So what's above mine?
The outside world.
Air?
Nothing, exactly, air. Nothing, it's an open space. And that's the key. Above the apical surface of an epithelial tissue is an open space, or what we call a free space. And again, you may not have thought of it in these terms, but you're aware of it. If we take the open space of my hand here, and then I curl my epithelial tissue up into a tube, what's the fancy name that we give for that open space in the center of a tube? I know you know
Cavity.
it. Cavity's not a bad term. That cavity would be close, but there's an even better term. What's the space inside of a hollow organ, or space inside of a lumen? There you go. Absolutely. So can be a lumen, right? It's always a free space, but if it's enclosed, we would call it a lumen. right? All lumens are free spaces, but not all free spaces are lumens. Again, fun with vocabulary. If enclosed, let's say it that way. It would be a lumen. So epithelial tissues are on top. So then below our epithelial tissues is some other type of tissue. It could be blood, pardon me, it could be bone, it could be a connective tissue. We have some other type of tissue underneath, and that underneath surface is what we call the bottom surface. So of course, we're not going to go with bottom. It's going to be basal surface. So we have an apical surface with a free space and a basal surface that connects it to whatever's underneath. Now, this connecting part is a teeny bit tricky. It turns out we need a little bit of glue. Wait, hold on. I didn't mean to do that. So let me rewrite that in dark blue. So there we have our basal surface, matching our apical surface. Perfect. But if we have some other tissue underneath, we need a little bit of glue to hold the epithelial tissue to whatever is underneath it. And of course, again, we can't get away with calling it just simply glue. We have to give some fancy name to this glue. And this fancy name, we call it is the basement membrane. Or, because our anatomists hate us, why give it one perfectly good name when we can give it two? It is also known as a basal lamina. Either of those two terms are 100% acceptable. So on the basal surface of all epithelial tissues, we have a basement membrane that holds it to whatever is underneath it. And again, remember, one of the things we've talked about these cells is that they could have microvilli. Let's not use that. Or cilia on the surface. So if I had cilia up here on the top of this cell, and I took the cell and rotated and turned it upside down, would it function the same way? No. So when we talk about it being polar, we don't mean that one side's positive and one side's negative. We just mean that it has different sides. It has an apical surface that faces the free space and a basal surface that faces the bottom and has the glue, the basement membrane that holds it in place. All right. Questions on that? Now, as I mentioned, these are very cell dense. Because they're cell dense, there's not a lot of room for other stuff. So one of the things that we know about our epithelial tissues are that they are all avascular. What does that mean?
Does that mean they don't get direct support for blood?
Absolutely. They have no direct blood supply. And again, you may not have thought of it in these words, but you're definitely aware of it, because if you scratch the surface of your skin, do you instantly start bleeding as a result of that every time you have an itch? No, if you want to bleed, you got to dig a little deeper, right? So we have that there on the surface, no direct blood supply to them. They're avascular. Doesn't mean they're dead. They're not dead. They just need, for instance, a blood vessel in the tissue beneath it to provide the oxygen and the nutrients that it needs by diffusion. In fact, and again, this is something else that you haven't thought about in these terms, but you absolutely know, epithelial tissues are highly mitotic. What's that mean again?
They divide and replicate very fast.
There you go. They divide rapidly. Right? What do you know about your skin cells here? You're losing millions of them every day. So can we see your muscles and bones underneath?
No.
No, because you're making millions more to replace them, right? All that dust on your computer screen, your TV screen, your kitchen counter, all of that is dead skin cells of you and everybody else living in your house. Enjoy, right? Absolutely. So they're highly, highly mitotic. You burn the inside of your mouth, right? And or bite the inside of your mouth or something like that. You know, burn it with hot chocolate or something, and in a couple days, it's totally fine. They're highly mitotic. They divide rapidly to replace because, again, they're forming that barrier. They're forming that important barrier, that important boundary. So they're highly mitotic, but again, no direct blood supply. Yes, this superficial layer of our skin cells are dead, but most epithelial tissues are not dead. They divide rapidly. And the other thing they are heavily innervated. Whoops. What does that mean?
They have a lot of like nerve endings, I guess.
Many sensory nerves, exactly. We receive a massive amount of information from our epithelial tissues, right? We're not even talking about taste like sweet, sour, and salty, but like we talked about the temperature of that hot coffee or that hot pocket when you take it out. Or how about your skin? You are getting a fire hose worth of information being presented to you from your skin. The feel of the chair on your back and on your butt, right? Or on your arms, the feel of your shirt on your shoulders, your socks on your feet. All that information is constantly coming into you and you're not paying any attention to it until someone like me points it out to you again and then you're aware of it. But we're receiving massive amounts of information from our epithelial tissues. All right, so highly mitotic, heavily innervated, but avascular. And like we said, they line surfaces, they form boundaries. But not impenetrable boundaries. We do want to allow some movement of materials. So they are also going to allow absorption and secretion. Moving things into or out of those surfaces. All right, I've done this here. Let's go back to the pretty picture and make sure we got everything. Notice here, we see our polar cells that have microvilli or cilia on their surface, apical surface with nothing above it, so that free space. Here we see the basal surface and that little bit of glue, that basement membrane that's down there as well. Now, if you're playing catch in the house and you break mom's vase and you use glue to fix it and put it back together, if you glue it back together well, do you see the glue? If you're fixing a vase and you fix it properly, do you actually see the glue?
No.
No. The same thing is going to be true here. In most of the tissues, there's going to be one exception, but in most of the tissues we look at, we are not going to see the glue. What that means on the exam is I will have an arrow pointing like this to the bottom of an epithelial tissue, and there will be two questions I can ask you. I could ask you to identify the surface, and of course, what would your answer to that be?
Basal membrane.
Basal.
Basal surface, excellent. Or I could ask you to identify the extracellular material found in this location. And what's the extracellular material, the substance outside of the cell that you would find in this location? Basement membrane, exactly. So again, 99.9% of the time in this class, we are not going to see the basic membrane. There's one exception where we'll actually see it. Most of the time, the glue is so good, we don't see it. We know it's there, but we don't see it. Okay? And when we look at some histology slides, we'll actually see that as well. As I mentioned, so cell dense, not a lot of room for blood vessels, but it is heavily innervated, highly mitotic, and because it's forming protective barriers, not surprisingly, it has a large number of cell junctions. All right. Questions on that? Yulia, yes, you had a question?
I had a question, yes. So people say things like, oh, massage encourages circulation, it helps blood reach the areas that hardly ever get enough blood. Is that true, or is that just hype?
So yes, stretching, massage, things along those lines can increase blood flow to areas like the muscles underneath. So primarily when you're doing that, it's muscles. You get congestion of blood in the muscles. And so that's what things like doing stretching or doing massage can help to increase blood flow too. It doesn't really affect the epithelial tissues on top. It's more about, congested muscles. So it's more about that. No, I don't have any reason why rubbing your skin would make it more healthy. No. Feels good. Feel free to do it that way. But nope. All righty. Excellent. Questions on that? So again, these are characteristics of all epithelial tissues, but they're also going to be specific types of epithelial tissues. And let's see how good your math skills are. 3 possible shapes, 2 ways we define them by their layers. So how many specific types of epithelial tissues are there going to be?
6.
I heard someone say it, I saw someone type it. Absolutely. As we know, there are going to be 8 specific types of epithelial tissues. Wait, what?
What?
Yep, there's 8. Why? Why are there 8?
Because anatomists hate us.
Exactly, because anatomists hate you. Excellent. So let's talk about those 8. Let's talk about the simple ones first. And here we see examples of the 3 obvious ones: simple squamous, simple cuboidal, and simple columnar. Notice each of these are made up of a single layer of cells. For the squamous, it's a single layer of flat cells. Cuboidal, single layer of cube-shaped cells. And for columnar, we have a single layer of tall, narrow cells. And let's talk about each one. Obviously, simple squamous is the, oh, this is going to be too big. Thinnest possible tissue, epithelial tissue, we can have. A single layer of flat cells. Now, we'll talk about where the 2 weird ones come in. Again, anatomists love to make rules and then throw you curveballs, and that's exactly what has happened here. Thinnest possible epithelial tissue. Now, is this going to provide a tremendous amount of protection?
No.
No, absolutely. This one's not about protection. So what's the advantage of having such a thin tissue?
Surface area and diffusion.
Exactly. This is going to be huge for diffusion. Right? Huge for diffusion because, again, if we need to, for instance, gas exchange, how important is it to get oxygen into your body and CO2 out of your body?
Super important.
Very.
Super important, absolutely, right? How long could you survive with a bag over your head?
Not very long.
Not very long, exactly. It is massively, massively important to get oxygen into your body and get CO2 out of your body. However, that entire gas exchange does not use any ATP. It is a completely passive process. So, not surprisingly, in places like the alveoli of the lungs, we are going to have that simple squamous epithelial tissue so that we can make it as easy as possible for oxygen to get in and for CO2 to get out. Yeah, we'll get to that one in a minute, Laura. Let's build up to it. All right. This is also going to be useful for internal boundaries. When we want to form a barrier inside, separate things on the inside of our body that are not exposed to the outside world, we're going to want to use the simplest tissue possible, the thinnest tissue possible, so it doesn't take up space. It doesn't have to provide protection. We just need a boundary. And in fact, the first tissue we're going to look at, we're going to see an example of that, where basically it forms a little cup that we're going to collect our filtrate in. Cuboidal. This is a fairly common tissue, single layer of block-shaped cells found in lots of areas of the body. However, it is very common in the use of ducts and glands. So if you're secreting some type of a substance or moving some type of substance in the body, having this cube-shaped tissue, making those ducts, making those glands are something that is going to be very, very important and very, very useful. Columnar cells, again, all of these are not going to provide a lot of protection because they're providing just one layer of cells. But these columnar cells do provide some filtration or allow for control of that movement. And primarily where we find simple columnar is in the digestive system. Now let's be more specific. It's not in the oral cavity, it's not in the throat. So it starts about 2/3 of the way. So the distal or inferior 2/3 of the esophagus, all the way to the rectum. Right? The openings, the anus and the mouth, those two openings are protected from the outside world. But the vast majority of our digestive system, the distal 2/3 of the esophagus, the stomach, the small intestine, and most of the large intestine are all lined with a simple columnar epithelial tissue, which notice can often have, but doesn't have to have, but can often have microvilli. Doesn't have to have microvilli, can, key word here being can have. Can have microvilli. All right, so those are our first three simple epithelial tissues, their functions, and where we would find them. Any questions on those? So again,
I have a question.
Yes, go ahead.
So because they are so thin, let's say it ruptures or there's damage to the surface, is that going to have a bigger consequence than if it was a multi-layered tissue?
Theoretically, yes, but you have to remember these tissues, because they're mostly internal, are not locations where they necessarily are going to come in contact with things that might damage them.
Okay. And then because they are only like single cell layer, if they die, do they have to be replaced like super fast?
Yes, in fact, these cells, and this is a great question, these cells here in the digestive system, these cells only last for about 3 days. Every 3 days, you're replacing the simple columnar cells of your epithelial tissue, right? Because you have those, spicy nachos, the sharp tortilla chip, the acidic wine, right? The hot coffee, not to mention the acid and all the digestive enzymes that are in your digestive system. They're all breaking down these very rapidly dividing cells. In fact, people who are undergoing chemotherapy, chemotherapy targets rapidly dividing cells. Often when people are undergoing chemotherapy, they have a lot of digestive issues because your digestive system is lined by these rapidly dividing cells, and they can be targeted by those by that chemotherapy as well. All right. Questions? Any other questions? Great question. Any others? All right, excellent. So those are the three easy, simple epithelial tissues. Let's talk about the fourth. As Laura pointed out, it is a ciliated, pseudostratified columnar epithelial tissue. Now, this, as you can see, is a big, huge alphabet soup term that you are going to be responsible for. All right, whoops, sorry. Clicking too many buttons. That you are going to be responsible for. But often when we have these big, huge alphabet soup terms, they tell you everything about them. Let's start easy. Ciliated. What does that mean?
Little things at the top.
Cilia.
Yeah, it has cilia. Remind me again what cilia are?
It moves substance across the surface.
Yeah, these are extensions of the plasma membrane that move substances across the surface of the tissue. Right? Pseudostratified. Pseudo, and again, I'll write it the way it's supposed to be. What does pseudo mean?
False.
False, exactly. Like chemistry is a pseudoscience, right? Pseudo means false. So notice this is a pseudostratified. It looks stratified. Let's jump back for a second and look at the simple columnar. Notice with the simple columnar, one of the ways you'll easily identify simple columnar is that all the cells are similar in size and length, and all the nuclei line up like ducks in a row. It's very, very uniform. Notice as we look here, these are not uniform. The nuclei look stacked, right? It looks like it has multiple layers of cells. But here's the key to that. It looks like it is multiple layers of cells. In fact, it's not. The cells are just irregular. So it's pseudostratified because it looks stratified. But in reality, is a single layer of irregular shaped cells. So it gives the appearance of being stratified, but it actually isn't. Instead, there are just a bunch of irregular, tall, narrow, column-shaped cells of different height.
I have a question.
And that is why it looks like that. Yes.
So by looking at this picture, is there a way that would make us know for sure this is pseudostratified versus the real deal? Because it looks like they each have like two nucleus.
Well, it does look like multiple layers, exactly. And that is what you're gonna notice. And in fact, we haven't looked at any stratified yet, so we'll get to those in a second, but you've got the right idea. One of the challenges to these tissues is when you look at these tissues, and if you just look down at near the basal surface of these, many of these tissues, this and many of our stratified, are gonna look almost identical. So what you really wanna focus on is the apical surface. When we focus on the apical surface, there's a couple things you're going to notice about, and I'll use the highlighter for this one. You're going to notice about the pseudostratified columnar. One is notice there, while there's many layers of nuclei, there really aren't a lot of nuclei up near the top. However, the most obvious thing that you should see are these big, huge, massive, long, thread-like organelles on the top. So if you see what appears to be multiple layers of cells and all these spiky hairs on top, well, guess what? This is the only thing that has cilia. So if you see cilia, guess what type of tissue you're looking at?
Pseudostratified cilia.
Yeah, ciliated, pseudostratified columnar. And again, I don't care the order. I always learned it ciliated, pseudostratified. Your book says pseudostratified, ciliated columnar. All I care is you have to have all three parts: ciliated, pseudostratified, columnar. So make sure all three parts are there for full credit. Now, the last question is, where do we find this particular tissue?
Trachea.
Absolutely. Trachea is one location. Where's the other one? Tongue? Is the tongue one of the areas? It's a good guess.
Oh, your nose?
Yeah, there you go. Think about where we move stuff, right? In your nasal cavity, you are constantly producing mucus. That mucus is being moved by those cilia towards the back of the throat so it can be swallowed or spit out. I think we talked about this already, right? Didn't we talk about this already? The cilia,
Yeah, when it gets cold or whatever.
yeah, it gets cold, your nose runs because those cilia slow down, right? Your trachea has this mucus elevator where the cilia move the mucus up towards your throat so you can spit it out and swallow it. We talked about how smoking damages those cilia. So you get that smoker's hat because that's how you have to remove that mucus from your trachea because of that. So those types of areas, in those two main areas in the respiratory system, nasal cavity and the trachea, are the locations where you're going to find this ciliated pseudostratified columnar epithelial tissue. All right. Questions on that? All right, let's switch back to whiteboard to talk about our stratified tissues. With our stratified epithelia, and again, there are going to be 4 of these, they remember are 2 or more layers of cells. So these are going to be a lot more about protection. Doesn't mean that they still can't have absorption and secretion going on, but they're going to be a lot more about protection. Now, I gave you 2 earlier easy examples. Let's say, for instance, I have a tissue that is comprised of 2 layers of tall, narrow cells. What type of tissue would that be?
Stratified columnar.
Stratified columnar. Excellent. If instead, I'm gonna totally cheat. Let's do this. Oops, no. Want that there. There we go. What if I have a tissue that is comprised of 4 layers of block-shaped cells?
Stratified cuboidal.
Stratified cuboidal. Excellent. But what if I have a tissue that is 1 layer of columnar followed by 4 layers of cuboidal, followed by a single layer of squamous? What type of tissue would this be? Is this the number 7 combo platter?
Stratified squamous.
But only 1 layer is squamous. Only 1 layer is squamous. There's 4 that are cuboidal. There's 1 that's columnar, 1 that's squamous. Pseudo?
Stratified squamous.
Okay, you are 100% absolutely correct. But my question for you is why?
Because it's on the top.
What?
Because it's on the top.
Bingo. The other rule we need to add to our stratified epithelial tissue is not only is it 2 or more layers of cells, but when we name it, we always name it based on the apical layer. Right? We want to be careful about top. We want to make sure we're using anatomical terms, but you're 100% correct. We always name our stratified epithelial tissue by the apical tissue, whatever is on top. So notice Here we have some cuboidal and columnar cells, but flat cells on top. This is a stratified squamous. This one's easy. Blocks on top, blocks on bottom. It's a stratified cuboidal. But notice this one have blocks on the bottom, right? Tall on the top. So this is a stratified columnar. So with our stratified epithelial tissues, we always identify them by the apical layer. What is on top? All right. Now, obviously, these are going to provide a lot more protection. Let's talk about the stratified squamous. Anybody have any idea where you might find the stratified squamous epithelial tissue?
Skin.
Yeah, absolutely. Right. Although it's a little bit tricky. And again, normally we're in the classroom, so I'm not allowed to do this, but you probably, you're not, I'll cover my bases, even though you've all signed the waivers. Do not do this at home. Okay. Do this only as a thought experiment. If you were to feel the outside of your cheek and you were to stick your finger in your mouth, which you're not allowed to do, I'm telling you right now, don't do it. But if you were to put it inside your mouth and rub the inside of your cheek, would they feel the same or would they feel different?
Different.
They feel different. But guess what? Both the outside of your cheek and the inside of your cheek are both stratified squamous epithelial tissues. So what's the difference? How can both the inside and outside of your cheek feel so different and have them both be stratified squamous?
The outer layer is, I don't know how to say it, keratinized?
Yeah, it is absolutely 100% of the way of how you say it. Absolutely. There are two types of stratified squamous. The reason I'm not allowed to tell you to put your finger in your mouth because who knows where that finger has been, and what if you get sick because you've been picking your nose or something and then you put your finger in your mouth and it's gross, or petting your dog or something. I don't need that legality. So if you want to do it, it's on your own, but I'm encouraging you not to. But absolutely, Laura's hit it on the head. It is that there are two main types of stratified squamous. There is a keratinized, which is what we find on our skin. Keratin is this nice, hard, rough protein that makes it hard. And then on the inside of our mouth, it is non-keratinized. This is the one that I think someone always already used the term moist, wet. There's one other big difference. Obviously, we need to be able to tell them apart under the microscope. What do you know about the superficial layers of your skin?
That.
There you go. The superficial layers of the keratinized stratified squamous are dead cells. They are dead cells because they're basically big bags of keratin, that protein. Our skin cells fill up with keratin, so much keratin that they're all, you know what, I don't need this nucleus, I don't need these organelles, and it basically chucks them. And the cells die and just basically become hard fused dead cells on top, providing protection. Whereas the cells in your mouth with the superficial layers of the non-keratinized do not have keratin. So there's no reason for them to die. There's no reason for them to get rid of their nucleus. So they don't have keratin, so they keep their nucleus and are alive. If you've ever done an intro biology class, Yulia, I see your hand, just give me a second. An intro biology class, one of the things you might have done is taken a toothpick, scrape the inside of your cheek, put it on a slide and looked at it under the microscope. And when you looked at those, right, you saw flat cells with nuclei in them because those superficial cells there were alive and had their nucleus. The superficial cells here are dead and don't have a nucleus. And that's how we're going to tell them apart. Yes, Yulia, I'll answer your question now.
So does keratin have anything to do with why they dispose of the cells and decide they don't need them anymore and let them die?
Well, again, remember, why is one of those questions we can't easily answer. All we know, and again, they're not the only cells that do that. That's what our red blood cells do. Our red blood cells fill up with a protein and then eject their nucleus. So red blood cells, mature red blood cells, don't have a nucleus. They're big bags of hemoglobin because their job is to carry oxygen. Our superficial layers of skin are dead, hard, fused together cells that die because they don't have organelles, they don't have a nucleus. They are fused together and made waterproof so they can't get oxygen and nutrients. And they provide that dead, hard, protective outer surface. All right. Excellent. These two, both stratified cuboidal and stratified columnar, are the least common tissue types in the body. They're typically only found in some of our large glands. So again, very easy to identify 2 or more layers of cuboidal cells or 2 or more layers with either cuboidal on top or columnar on top. But they're the most rare tissue in the body, only found pretty much in large glands. So we're not going to even worry about them. In fact, if you've looked at your histology list, which hopefully you have, because if you haven't, first and foremost, shame on you. But notice you are actually not responsible for these under the microscope. So I will not show you any images of these under the microscope. If I asked you to identify all of the epithelial types or all of the stratified epithelial types, right, and identify where you'd find them and identify their characteristics, you would definitely be able to do that. But I'm not going to show a picture of them under the microscope that you're going to be responsible for. So if you see a histology slide, stratified cuboidal, stratified columnar is never going to be the correct answer. All right. Excellent. So that brings us to our last, again, the curveball that they've given us. And in this case, the curveball is a tissue type known as transitional epithelium. Transitional epithelium gets its name because the cells can change their shape. Notice in this first picture, the cells are mostly tall columnar cells, where down here, they are more cuboidal. And in fact, this tissue can actually be stretched out until it was a single layer of flat cells. So that's where it gets its name, transitional, because it can change its shape. The question then becomes why? Why is it important that this tissue can change its shape?
For the bladder.
Well, bladder is definitely where you find it, absolutely. But why might it be important in the bladder?
To hold
Increase volume.
contract.
Okay. True. Well, so not so much that it helps him contract, but all right. Let's say, I think part of the problem is we haven't had this important conversation that an anatomy and physiology instructor and a student needs to have at one point in their life. Children, what is it that makes the world go round? I know some of you are thinking money. A lot of you are thinking love. There you go. Madison's got it. What truly makes the world go round is pressure. Pressure is the most important force in the world, right? And pressure is what makes the world go round. And so controlling pressure is vitally important. It would be very easy to make a bladder just like a balloon, right? Balloons are a great example of pressure. If I had a balloon right now and I put just the tiniest bit of air into it and I let it go, what would happen to that balloon with just a tiny bit of air in it?
Fly.
Would it really? If I just that much air into it, would it really fly?
No, it would fall.
Pretty much just fall to the ground. However, if I filled it up and let it go, what would happen?
It'll fly.
Then it'll fly around the room, absolutely. And why does it fly around the room? What's the difference in those two situations? Pressure. In the second example, I have filled the balloon with more air, and a balloon is elastic. And that elasticity, as it expands, it wants to recoil and go back to its original shape. And the more you stretch it, the more it wants to go back to the original shape, and the more pressure it builds up. Well, what does that have to do with us? Well, as someone mentioned, we got our bladder right there, right? And when you need to go to the bathroom, you avoid your bladder. But what if you're sitting in the car when you realize you need to urinate and you just passed the sign that said it's 35 miles to the next rest stop? By the time you get to the next rest stop and your bladder's filled up even more, do you fly around the room when you finally release the urine from your body? No. And the reason for that is that this transitional epithelial tissue allows the bladder to expand with a dramatically with a dramatically less pressure. Let's say it this way, with a dramatically less increase in pressure. Now, does urine come out of a full bladder stronger with a faster stream than it does in an empty bladder? Yes, absolutely. But for as much as it stretches, if it was just elasticity, it would be even more pressure. So this gives us much more control of the pressure of our bladder. And so not surprisingly, this transitional epithelial tissue is found exclusively in the urinary system. This is in the organs and only in the organs of the urinary system. So that means the ureters, the two ureters that bring it from the kidney to the bladder itself, and then the urethra going out. Those four structures, and only those four structures, are lined with a transitional. Now, again, we get back to why. I see there's two hands. Give me a second. Where would another great location to have this tissue be? Where else do we have something that needs to expand to the size of a basketball and might be nice to be able to accommodate pressure?
Uterus.
Yeah, about the uterus, right? Absolutely. The uterus would be a great example of where that would be, but it's not there. I don't have a good answer for why. I'll answer Amanda's question real quickly first because I saw that one, and then I'll answer the two that raised their hands. Skin does have some elastic fibers in it, which does allow some stretch, right? But again, it's not this transitional tissue. Remember, our skin is the keratinized stratified squamous epithelial tissue, and it's actually the dermis underneath, the connective tissue underneath, that has the elastic fibers that allows that stretch. I don't remember if I've told this class or not, but my brother-in-law, his senior year in high school, grew 12 inches. Massive, massive amount of growth in that time. And so not surprisingly, he has some pretty dramatic stretch marks on his side because he stretched his skin beyond its elasticity. Laura, you had your hand up?
Yeah. So I don't know if this kind of ties into it, but like the heart, would it be this type of tissue or would it be a different one?
It's not found in the heart. Again, this is only in the urinary system. It might be useful in the heart, although as we'll learn when we get to the cardiovascular system, when it stretches more, we actually want it to produce more pressure. So there we actually want to take advantage of that elasticity. So when you fill more blood into it, it can pump more blood out. So there we actually don't want to reduce the pressure. We want to increase the pressure there. So it would help us that way. Was there another hand that was up?
Yeah, it was mine, and I was going to ask you about the tissue inside the uterus, and you already answered it, but I didn't catch it. Does it have transitional epithelium, or it does not?
No, it's the urethra is lined basically by a non-keratinized stratified squamous. It's not transitional. Again, it would make sense to have it there because it does need to expand.
Yeah.
I don't, again, why I can't answer. What I can tell you is transitional is only found in the urinary system.
Okay, then what kind of, I'm just super curious, what kind of tissue do we have in our uterus?
The non-keratinized stratified squamous.
Okay, thank you.
Yep. All righty, so there you go. They are indeed, absolutely, because they get the honor and the privilege of housing and growing a small basketball inside of them. All right, how are we on time? We are doing good. Okay, perfect, excellent. All right, so here's the game plan. We have identified these tissues, and we still need to talk about the gland stuff. But I think before we talk about the gland stuff, I actually want to do some histology. So what we're going to do here is we're going to go ahead and take our next break. It is 2:05 right now, so we'll restart at 2:20. And at that point, we'll start the recording again. But at this point, we are going to switch gears to our histology. So if you have not already printed out your epithelial tissue handout, first and foremost, shame on you. But secondly, do so now, or at least bring it up on your iPad or laptop or something like that, so that you can follow along and look at it while we talk about and discuss it. All right, because that is what we're going to be doing next. All right. Questions on any of that? It's in the lab handouts of our module. All of the lab handouts are in your module. So under the lab handouts in your module for section 2 is where you will find it. All right. All right. I will see you guys in 15 minutes. All righty. Let's go ahead and get started. So what you should have in front of you is something that looks a little like this. This is your study guide for the lab exam, and it's going to be about somewhere between 1/4 and 1/3 of your next lab exam, because we also have connective tissues, we also have the skin, and there's some overlap. There are a couple of key pieces of information on here that I want to make sure you appreciate and understand. This is the list of the things that you are responsible and I could ask you for on a microscope slide. This is where if you'll be using your Histology Atlas a lot to get started with this. Certainly you can put a search for simple squamous epithelial tissue into the almighty Google, but when you put it into the almighty Google, you're not necessarily going to get all images of just the simple squamous epithelial tissue. And if you don't know what you're looking at yet, it can be hard to tell what's true and what isn't. So it is much better to use your other resources, your textbook, your lab manual, your practice anatomy lab or professional anatomy lab or whatever it's called, personal anatomy lab. There you go, the PAL that is on your Mastering A&P. All of those are great places to see good examples of these tissues. Then, as you start feeling comfortable, then go to the almighty Google to do a search to see simple squamous epithelial tissues at different stains and different orientations and different magnifications and things along those lines. The other thing that you will see on here is the list of material you are responsible for. And notice next to them in parentheses are the term that I will be holding you responsible for on the exam. So let's say, for instance, oops, wrong button. The very first slide on the exam happens to be a slide that looks a little something like this. And I ask you to identify the specimen in the field of view. Guess what your answer to this question is?
A kidney.
There you go. How did you know that? Because you recognize this tissue?
Duh. No, because it's on the piece of paper.
There you go. It's the very first thing on the list, and that's the very first term I used. Absolutely. And so that is why. Now, obviously, I'm not going to go in order on the exam, so we need to figure it out, but you're absolutely correct. Basically, what specimen means is just a fancy way of saying, what is the label on this slide? What is the tissue or the organ or the structure that I am looking at? And what we are looking at right now is a kidney. The way we can tell that what we're looking at right now is a kidney is because of this special structure right here. And what do you think this entire structure might be that I've just done a very poor job of circling?
The renal structure?
Yeah, oh yeah, well, it's not renal structure. What is it called? Corpuscle. And again, I don't care how you pronounce these things as long as you spell them correctly on the exam, but you're absolutely correct. This is a renal corpuscle. This renal corpuscle is basically made up of 3 components. The first of these is this thin line right here. What layer do you think this thin line that I'm highlighting with blue might be?
The Bowman's capsule?
Exactly, that layer. So again, it is on Canvas in your modules is where you will find these handouts. Absolutely. This is Bowman's capsule. However, notice I could also take that thing I just highlighted in blue and ask you to identify the tissue type. And what tissue type is this that I just highlighted in blue?
Simple squamous epithelial.
Exactly. Oh. And again, this is exactly what I've talked about in the past on the exam. Hold on, I'm going to erase this for a second. Everything. On the exam, I could have an arrow like this. This could very easily be the first slide on your exam. And this very easily could be exactly what it looks like. And notice with this particular slide and this particular arrow, there are at least 3 questions that I could ask. So I'll ask them. Identify the layer.
Bowman's capsule.
Yep. Identify the tissue type.
Simple squamous epithelial.
There you go. Identify the organelle.
The nucleus.
There you go. Notice I never moved my arrow, but by using the exact keyword that I have given you in those parentheses, I have told you exactly what piece of information I am interested in. Again, my goal on the exam is not to be tricky. What I need to do is be precise. So I will be very specific about the way I word my questions, and I don't want it to be confusing. That is exactly why I've given you this list with not just the information, but the exact key term I will hold you responsible for. So let's take a step back. In this circle is a structure known as the renal corpuscle. And as I mentioned, that renal corpuscle is comprised of 3 things. The first thing, as we just saw, was Bowman's capsule. Oops. Bowman's capsule is also sometimes referred to as the glomerular capsule, which is a perfectly acceptable term to use as well. It is also comprised, and I'll use green highlighter for this one, of this big squiggly looking thing here. This big squiggly looking thing here is a big, highly specialized capillary. This big, highly specialized capillary is what is known as the glomerulus. Do you need to know that?
It's not on the handout, so.
Not on the handout, so the answer is no. We need to know that it's a part of the renal corpuscle, but I'm not going to point an arrow at it and ask you what it is. It's just a big specialized capillary. And its job is to filter the blood. Basically, we produce 200 liters of filtrate during the course of the day. 200 liters of stuff comes out of your kidneys, out of your blood. Now, do you produce 200 liters of urine?
No.
in a day?
No.
No, we'd all be sitting in the toilet doing this lecture if that was the case. And does anybody have 200 extra liters of fluid in their body they can afford to get rid of during the course of the day? No, of course not. So we end up reabsorbing most of that. But it still has to come out. It still has to be filtered. It still has to be processed. And that's what happens. The blood is filtered out of the glomerulus, out of this capillary, to produce a substance called filtrate. And that filtrate is caught by this big cup known as Bowman's capsule. But notice there's this space in between. This space in between is the third component of the renal corpuscle, and it is known as Bowman's space. Now, of course, why is it called Bowman's space and Bowman's corpuscle? What do you think?
Probably the guy who found it or something.
Yeah, good old Bob Bowman was the first person who discovered it, or at least the first one who wrote it up or took a picture of it and posted it in a journal. And of course, like most anatomists, he named it after himself. So there you go. We have Bowman's capsule and Bowman's space, and that capillary that collectively form the renal corpuscle. All right. And I think that's everything for the simple squamous, yes? Did I forget anything? Don't make me look.
Go back really quick. I was writing down the last one. Okay, thank you.
I think you got it all.
Excellent. And again, all of those are on your list. So, let's go ahead and do this now. Your job, and don't be doing it now, because if you're doing it now, you're not paying attention to me and what I'm talking about. But on your own time, what you're going to be doing on this handout is what I just did. Using your pencil and your paper, or your iPad, if you can save it as a PDF or whatever, you're going to be drawing everything that I just did, right? So first is going to be that big glomerulus, that capillary, and then I'll even change colors because I have the ability here. I'm going to have that single layer of flat cells around it. So there's my single layer of flat cells. And in that single layer of flat cells, I can often see a nice big nucleus in here as well, right? So something that looks a little bit like that. Then I'm going to label everything. By labeling everything, I don't mean that you're going to say that this is Bowman's capsule or this is the simple squamous. You are not going to use arrows and do it that way. You are not going to put a number over here. Renal corpuscle is 1, and then put some 1 over here someplace. No, I want labels. You are going to draw an arrow to one of these things, and you are going to write out that this is Bowman's capsule. Right? If you do not label these things, you do not get credit for doing them. All right? I am not grading you on your drawing skills. You've seen my drawing skills. I am no artiste. But you are going to put the time and effort into learning these because this is an easy way to get you to understand how important histology is. Easily over half of this exam could be histology slides. So forcing you to do this is an important way to you get right off the bat, start to appreciate and understand what it is that we're doing and how important this histology is. And you will be turning this in for a grade. Doesn't need to be color. Again, you can do these pencils or pen or whatever. Not grading you on your drawing skills or how accurately it looks like what it was on the slide. But what I want this to be is a good study tool for you to help you to understand these tissues. So draw it so that it makes sense to you. And by having the labels here, you have the perfect tool to be studying this material and helping you to be successful. and you will be turning this in for a grade. And so you will be scanning these or taking pictures of these after you do this. And it is due February 16th. So 2 days before the exam. So it's a perfect thing to help you to be successful. All right. Questions on that? All right, now that you understand what you're going to be doing on your handout, let's continue to the next one. Notice, Yulia, you have a question.
Yes, so I can't find that image you're talking about. Granted, I ran out of ink, but where is that picture located that you keep basing everything off of?
This picture?
Yes.
These slides are not something that I necessarily made available. Some of these are from your textbook. Some of these are just things that I found on Google. But what you will do is you can go to your Histology Atlas, your photographic atlas of histology, and you can find, for instance, in there, look up kidney or look up epithelial tissues. When you look up epithelial tissues, right in here, you'll see they do. And again, one of the things that I love about this is not only does it show you the tissues, but it's got nice illustrations. It describes these things. There is a lot of really good information in here. So we have lots of really great examples. Oh, and look at that. Lo and behold, on page 31 of your Histology Atlas, you have a nice pretty picture there of that renal corpuscle, just like we're looking at right now.
Shut up. I can watch this as a lecture later. My best friend is here.
Well, then by all means, go be with your best friend.
There's a place called Falling Prices where, like, if, for example,
go ahead
Target
and move
receives
that.
an item.
Yes, excellent. The CRC virtual app also, I think, has some histology. I don't know how spectacular that is, but I know they have some, so you can look and see what's there as well. Lots of resources. Use all of your resources, right? You paid money for a lot of this stuff. Use it. All right. All right. Well, and again, when you go to your Histology Atlas, when you go to the CRC, Yale, that Yale site is a great histology site, really, really in depth. And some of those things may be more in depth than we need, but you have a precise list of exactly what you are responsible for. Now, notice here in the kidney, this renal corpuscle isn't the only thing we see. We also see this thing right here. Notice this thing right here is basically a flat layer of cells that have been rolled up into a tube. Oh, great question. How do you know it's a kidney? Remember this big fancy looking thing we called a renal corpuscle. Guess how many places in the body you find a renal corpuscle? One. Exactly. So if you see a renal corpuscle, you know you are looking at the kidney. It's a dead giveaway you're looking at a kidney because the kidney is the only place you find it. Now this, on the other hand, you find lots of places. No, each one of this right here is a single cell, and it's next to a single cell, and it's next to a single cell. This is a microscopic view of the kidney. So one of the things that I would encourage you is also on Canvas is a histology guide. For those of you who are not as familiar and comfortable with the microscope stuff, that can be something that can be helpful to read that guide to understand how we are taking thin sections of a three-dimensional structure and looking at them under the microscope to understand that. Now, this structure right here, also in the kidney, because we know it's next to the renal corpuscle, is basically a single layer of cells that have been rolled up into a tube. What do you think we call this structure?
A lumen?
Well, okay, the space would be the lumen. So if I asked you to identify the space, lumen would definitely be acceptable. But what is the structure that has the lumen in the center of it? Renal tubule. There you go. Excellent. It's a tube, right? And it's in the kidney. Makes it a renal tubule. Excellent. Now, notice this is made up of a single layer of block-shaped cells that have all been put together into a single roll up into a tube. So what tissue type is this?
Cubital.
And you get partial credit for that on the exam.
Simple cubital.
Simple cuboidal or cubital epithelial tissue. Excellent. And of course, identify the organelle.
Nucleus.
Nucleus. Let me clear up my drawing here a little bit. Identify the surface. There you go. Ariana's got it. Apical. Identify the surface.
Basal.
Identify the extracellular material you would find in this location.
Basement membrane.
Basement membrane or basal lamina. Excellent. Right. Again, remember, we're not going to see the glue, but we know it's there. Notice here we see the exact, oh, let's go back actually one other thing. Again, this tissue here is also an epithelial tissue. Does our simple squamous epithelial tissue have an apical and a basal surface?
Yes.
Yes, because all epithelial tissues have it. However, is it as easy to point it out on this, on the simple squamous compared to a simple cuboidal, or is it easier on a simple cuboidal? Right, I mean, I guess maybe I could do it. I could grab this, and maybe if I pointed like that, be comfortable with that being the apical surface? Maybe that being the basal surface, but isn't it a lot easier to do it over here? Or how about here? Identify that surface.
Basal membrane.
Surface.
Basal surface.
Basal surface. Here, I'll give a blue one too. Identify that surface.
The apical surface.
Apical surface. Yellow arrow. Identify the extracellular material you would find in that location, or the matrix you'd find in that location.
Basement membrane.
Blue arrow. Identify the space.
The lumen.
Yeah, lumen. Or what else could you use?
Apical.
Remember, a lumen is just an enclosed what?
Free space.
Free space. So you could also call it a free space. Lumen would be fine. Free space would be fine. All right. Identify the organelle.
Nucleus.
Identify the tissue type.
Cuboidal.
Simple cuboidal.
Simple cuboidal epithelial tissue. Excellent, right? So again, notice it's just a simple cuboidal that they've rolled up into a tube. All right. Now, these also happen to be renal tubules. All right. However, on this particular slide, is there any renal corpuscle that tells us that this is the kidney?
No.
No. So there is a second way that I can ask that specimen question. The other way I could ask that specimen question is to say, identify one organ where you would find, or region of the body where you would find this tissue type. And so we know simple cuboidal would be found in the kidney. So that would be one place where we could find it. Notice I could also ask that question here. Identify the tissue type.
Simple columnar epithelial.
There you go. Identify one location where you would find this tissue.
Stomach.
Stomach. Any other correct answers?
Digestive system.
Not specific enough. I want a specific location. So stomach was good. Where else?
Lung.
Yes.
Small intestine and large intestine. And remember also the distal part of the esophagus, a little bit of the esophagus as well. Digestive system is a correct answer, but you would only get partial credit for that. I want a more specific location, like the stomach, like the small intestine, like the large intestine, like even the distal esophagus. How do we know this is simple columnar?
One layer. Because the cells are tall and the nuclei are at the bottom.
True. Well, not only so much that they're at the bottom, but they're uniform. All the cells are kind of the same shape. All the nuclei are in the same location. However, notice there are a couple cells like this cell here that do disrupt the layer a little bit. These are these kind of big bulbous cells. Anyone have any idea what we might call this big bulbous, right, cell?
Is that a goblet cell?
It is a goblet cell. Notice because it is chock filled with this protein that it is going to release that gives it a shape like the big bulb of a goblet. Anyone know the substance that this goblet cell might produce? What does it contain?
Mucus.
Mucus.
Close. It is something that is going to make mucus. So what happens is these goblet cells make a special protein. And when they release that protein, it mixes with water and it becomes mucus. So it is going to become mucus, but what's the actual substance that the cell has inside of it?
Mucin.
Mucin, absolutely. Mucin is the protein. Now, one more quick question. Are these nuclei in your cell? If you were to actually cut open your stomach and look at it right now, would the nuclei of those cells all be this beautiful bright purple like we see it right now? No, of course not. We call this an artifact. An artifact is basically a fancy term we use for some characteristic of our slide that isn't there in real life. Because again, remember what we had to do. We had to cut out a piece of the stomach. We had to freeze it. We had to slice it really thin. We had to mix it with all these chemicals, lay it on a slide, put some glue on it, right? Hit it with light, do all these types of things. So it isn't necessarily that it isn't not. So yeah, so absolutely. The stain makes these things visible. Absolutely. These are stained for visibility. So the color is usually something we can ignore. Of course, the key word where there was usually. An important rule to remember in histology is color doesn't matter except when it does. And this is a perfect example of it. Mucin, this protein mucin, happens to be a substance that almost no stains bind to. So notice all of these goblet cells are there's even a little bit of one there, a little bit of another one down here, are big, not only the big, round, and bulbous, but they're very, very clear because that mucin doesn't like stain. Very few stains bind to it. And since no stains bind to it, it tends to have a very clear color. So it makes the mucin and therefore the goblet cells very easy to identify. All right, a couple more things on the list. Identify the surface.
Apical.
Apical. Identify the organelle.
Microvilla.
Microvilli, right? Absolutely. This is the stomach. This is the small intestine. These are for absorption. That brush border we see on the top is for absorption. Identify the organelle.
Nucleus.
Identify the surface.
Basal surface.
Basal surface. Identify the extracellular material found in this location.
Basement membrane.
Identify the space.
Free space.
Free space. Identify the surface.
Basal.
Basal?
Oh, apical.
Apical. Notice basically these two are basically facing each other. All right. So again, this is the space where that cheeseburger you had for breakfast would sit. But here the folds are kind of collapsed on each other. So this is apical facing the free space. This is apical facing the free space. Right. I would be careful about adjacent because I would say these two are adjacent cells. they're actually together, right? These are just folds that have kind of come together towards the center. So they're near each other. But again, this just as easily could have a big, huge cheeseburger here, pushing them apart. These two cells aren't going to be pushed apart. Excellent. I think that's everything for this one. Again, different magnification, but here we see those folds a little bit better, right? So again, here we see, and again, that nice, simple, columnar, very uniform shape. Identify the substance.
Mucin.
Mucin, right? So again, exact same thing. Basal surface, apical surface, cilia. Again, I've given you the list. I've given you the terms. This is what you are going to be responsible for on the exam. Now, compare this, where all the cells are similar in length, all the nuclei line up like ducks in a row, and this. Are all the cells perfectly uniform in shape? Are all the nuclei perfectly in rows?
No.
No. This looks like it is multiple layers, but then when we look at the top, we see these big hair-like extensions on top. We see little to no nuclei near the top. So absolutely, this absolutely is what?
A pseudo.
Right. Of course, are we going to get away with just writing pseudo on the exam?
A pseudo-stratified.
Pseudostratified, ciliated epithelial.
And you get partial credit for that. There's really 4 things you need. Pseudostratified, ciliated, what else? Columnar and epithelium or epithelial tissue, absolutely. So all 4 things are necessary. Trust me, in a couple of weeks, ciliated, pseudostratified, columnar, epithelial tissue will roll off your tongue just like it rolls off my tongue. And more importantly, I don't even care if you can say it. You don't have to say ciliated, pseudostratified, columnar, epithelial tissue. You just need to be able to spell ciliated, pseudostratified, columnar, epithelial tissue.
That sounds like it could be a rap.
And yeah, exactly. I've been working on that that monster from Eminem, because I figure if I can say ciliated, pseudostratified, columnar, epithelial tissue, I can do that.
Teacher got
All right.
bars.
Excellent. Spelling hasn't been so bad, but again, it gets worse with the tissues. One more question. Identify a location where you would find this tissue.
Yeah.
Where?
Nasal cavity.
Nasal cavity and
The trachea.
Trachea, right? These are the ones that move the mucus. Now remember, simple columnar is found in our stomach. All right, those are our simple tissues. Let's switch to our stratified. Again, notice if we just look down here and we just look down here, these 2 tissues, obviously they're different colors, different magnifications, but they look pretty similar. However, notice what we see when we look up here at the top. What type of tissue is this one here?
Simple squamous. Epithelial.
Simple? Do I only see 1 layer of cells here?
Oh, stratified squamous epithelial.
And you would get partial credit for that on the exam. This is indeed a stratified squamous epithelial tissue. However, remember we said there are 2 flavors of stratified squamous epithelial tissue, the inside the mouth and the outside of the mouth. So which one is this one?
Non-keratinized.
The non-keratinized.
Non-keratinized. How do you know?
Because the keratinized has like a thick layer of keratin on top.
Yeah, thick layer of dead cells on the top. Notice here we have flat cells on the top, but these flat cells on the top, exactly, Yulia's got it, are not dead. So you can either have keratin or you can have a nucleus. This one has a nucleus, so these are non-keratinized stratified squamous epithelial tissue. Identify the surface.
Apical.
Apical. How many basal surfaces does this tissue have?
Would there be 2?
We'll get to the carinized. We'll get there. We're working towards it. So how many apical surfaces does it have?
One.
One. How many basal surfaces does it have?
One.
One. Right? Apical is the top, basal is the bottom. Apical surface, basal surface. For this arrow down here, the bottom arrow, identify the extracellular material found in that location.
Basement membrane.
Basement membrane. And again, notice how easy it is to find that basal surface. Remember, here, let me do some quick erasing. Our epithelial tissue is cell dense. Connective tissues we haven't talked about yet, but guess what? They're cell sparse. So notice we can very clearly see where the cell dense epithelial tissue begins and where the cell sparse connective tissue ends. And so that border is the basal surface. And even though we don't see the glue, we know the glue is there, and that glue is the basement membrane. All right. Yes, Sydney.
So there wouldn't be a basal membrane in between, or
nope.
Yeah, there wouldn't be a basal surface in between each type of cell when
Correct. Even if there are 100 cells here, you still just have one top and one bottom.
Okay.
So in between are not individual layers. You have the bottom of the tissue and the top of the tissue. So apical on top, basal on the bottom. I have a question. Identify, oops, that color doesn't work. Identify the space. Free space. Can we call it anything else? Is this a lumen?
Lumen or no?
That's what I'm asking you. Lumen or no?
It can be.
It could be, but we can't see the other.
True, we can't see it. So then the question becomes, where would we find this tissue? Identify one or more locations where you would find this tissue.
Your lips.
Okay, careful on the lips. It's not so much on the lips, but on the inside. So the inside, the cheeks, the oral cavity, inside the mouth.
Esophagus.
Where else? Esophagus, proximal 2/3 of the esophagus. Of course, that means in between. Oops, in between our pharynx, would as well, our throat.
Are you asking for the lumen?
Well, I'm asking where you would find this non-keratinized stratified squamous epithelial tissue.
Would you find it in the intestines as a lumen?
So remember, we did not in the small intestine, not in the large intestine, most of it, but remember at the end of it where it's open to the outside world. So the anus would be one of those locations where you'd find it. This protects openings to the outside world. So notice we mentioned our digestive system. Do we have any other organ systems that are open to the outside world?
But, I mean, reproductive.
There you go, the vagina. The distal end of the urethra. Yes, you do have it over the conjunctiva of your eye has it on it as well. So not so much the eyelids themselves, but on the white part of your eye, you do have it on the white part of your eye.
What are your lips made out of then?
Your lips are actually a very thin keratinized stratified squamous. Nope, ears would be stratified squamous as well, keratinized as well on the inside of that for the most part. So respiratory passageway, right? The very beginning of the nasal cavity, urinary, reproductive, and digestive. Those four areas where we have that moist openings, those are the areas where we would find this, and over the surface of the eye, which is also moist as well. And notice if you look at all those, I guess with the exception of the eye, all of those are enclosed spaces, whether the anus or the vagina or the oral cavity. So technically it would be a lumen. But again, obviously, it's always going to be a free space. So free space is always a safe answer. All right. What do we got here?
Skin.
Keratinized.
There you go. Tissue type. You're right. I didn't ask a good question. So if I asked you to identify the organ, skin or integument would be good. If I asked you for the tissue type, what would your answer here be?
Keratinized.
Stratified.
Stratified squamous.
On this epithelial
Epithelial tissue.
Excellent. Again, you've got 2 whole days before, we have 2 whole weeks, I'm sorry, before your exam. So that's plenty of time to go to London for the weekend. And when you go to London, you're of course going to meet the Queen. And when you meet the Queen, she's going to put out her hand to you. And when she puts out her hand to you, what do? You
kiss it with honor.
You kiss it. Keratinized, stratified squamous epithelial tissue. When someone presents their skin to you, their keratinized, stratified squamous epithelial tissue, you kiss it. Now, let's take a closer look at this picture. Notice we can tell this is a keratinized, stratified squamous epithelial tissue because while we have plenty of cuboidal and columnar cells down here, the cells up here are all flat and none of them have a nuclei. They're also all hovering in space. Is that what the superficial layers of your skin do? Do they hover in space above your skin?
No.
No. This is a perfect example of that artifact we were talking about before. Because here's something else you know about skin. Maybe instead of going to London for the weekend, you decide to go to Florida for the weekend, right? Let's say you're one of those people of poor intelligence who happens to like Tom Brady and decide to go to celebrate at Disney World with him, right? Because you like cheaters. So there you are celebrating on the beach and you get a nice big dark tan, and maybe not even more than a tan where it gets red. You damage and destroy those cells of your skin. And those skin cells that get damaged, do they just fall off as tiny little pieces? Or even dead and damaged, do they peel off in a continuous layer?
They peel.
They peel. Our skin cells are fused together, waxed together, held together very tightly. So when we freeze this tissue and cut this tissue, what actually happens sometimes is you will see this shredding of the cells where it kind of comes apart like this, right? And so obviously this is obviously not how it is. It doesn't float in space above the skin, but it is an artifact from that, but we can still see that. And while I'm on my high horse, let's talk about one other thing. You guys are going to discuss this in the homework assignment, skin color, that is due on Thursday. Notice this little bit of dark substance down here. Does anybody know what that might be?
Keratinocytes.
Well, the cells themselves are keratinocytes, but anybody know what this reddish dark color is? Melanin, right? Melanin is produced by skin cells called melanocytes to help to protect the cells from UV radiation. Someone who has incredibly dark pigmented skin, this is what their skin would look like under a microscope. In the deepest layers of their epidermis, they have this dark pigmented material down in here, whereas someone who was light-skinned, theirs would pretty much look like this over here, where you wouldn't see anything in the lower layers. And histologically, if you look at the whitest white person and the darkest dark person, that is the only difference biologically in them. And so when you think of the type of strife and heartache and problems, not just in the past year, but in the past hundreds of years that have occurred because of skin color, and then when biologically you look and see how little and insignificant those differences are, it is truly appalling. Now, this happens to be thin skin like you would find on your forearm. This is what the skin on the bottom of your foot looks like. Notice here we have a much more massive layer of dead flattened cells, hundreds of layers of dead flattened cells. But notice, not a nuclei in this anywhere. The cells start with nuclei, and again, notice how clearly we can see the basal surface of our skin versus the connective tissue underneath. One basal surface, one apical surface, hundreds of cells in between. Many of them start with nuclei, but then we have this massive layer, thousands of cells, just chock filled with keratin, providing us with that big, hardened, thickened protection. So again, notice we look down here on this. If we look down at the bottom, basal surface, come on, of this, if we look at the basal surface of this, they all look the same. We can tell these three apart by looking at the top. Cilia on top, living cells on top, dead cells on top. The apical surface is what tells you which of these three tissues are which. Well, you still know it. You can still know it when you walk on it. You still, you know, people who walk on coals, they still feel it as well. But yes, we have a lot of protection down there. Absolutely. Now, what is this?
Stratified Cuboidal.
Not a bad guess, but remember, I wasn't going to hold you responsible for stratified cuboidal histologically. And in fact, stratified cuboidal is not on your list of histology slides that you're responsible for.
Then there would be stratified transitional epithelial tissue.
Absolutely. This would be transitional. Absolutely. All right. This is transitional. Now, again, notice if we just focus down here at the bottom, it looks like everything else. But notice here, as we go towards the top, not only do we have nuclei, not only do we have cells, but instead of the cells getting smaller and flatter, the cells get bigger and larger. And look how we have these big, huge block cells up near the apical surface. So notice, unlike every other stratified tissue we've looked at, these actually get bigger as they get towards the top, whereas everything else we saw got smaller and flatter. That is a give, that tells you we are looking at a transitional. However, as I mentioned, there is some challenge in recognizing these tissues. Again, we can clearly see the basal surface, the apical surface, yammer, yammer, yammer. But when you're taking this test, you're always looking for things that are going to be a dead giveaway. That when you see them with 100% certainty, you know what they are. Cilia, dead giveaway. You're looking at a ciliated pseudostratified columnar epithelial tissue. And this tissue sometimes, not always, but sometimes when you see it, it is a dead giveaway. Notice we talked about how there are the big block cells up on top of this tissue. But what do you notice about this cell right here?
There's two nucleus.
If you see one of these big block apical cells that has two nuclei in them, that is a dead giveaway. You are looking at a transitional epithelial tissue. I don't know why some and only some get it. And not every transitional epithelial tissue will have it. But if you see it, you know you are looking at a transitional epithelial tissue. All right, so let that be one of your dead giveaways. And one last question. Where would you find this tissue?
Bladder. The ureter.
Right, ureter, bladder, urethra. Excellent. All righty. That is how the game is played. Questions on this?
So from my understanding, we did a little bit from both chapters. Is that correct? Today, or did we go through one of the chapters and start with the second?
We are focusing on tissues, but you are correct in that in talking about tissues, we did go back briefly to the cells chapter to talk about cell junctions. I think you want to focus a little less on chapters and more on topics, right? Remember, the textbook isn't a romance novel that has to be read from cover to cover. So focus on the concepts we've talked about and then find wherever they are in the textbook. We tend to go in order. And so yes, we are working our way through tissues, but we still have epithelial tissues to go. I mean, connective tissues to go. And then we have to put them together in membranes. So we've barely scratched the surface of tissues. We're still just starting that. But so we're focusing mostly on tissues, but we did briefly go back to cells to talk about cell junctions. Okay. Good question. Any others? All right. This is an example of what is going to be expected of you. These are the types of slides that I'm going to show you. These are the types of questions I'm going to be asking you. This is the stuff you need to get familiar with. And while every once in a while, like these two nuclei, you'll get a dead giveaway, most of it's going to come with practice. So you're going to need to put time and effort. And that's why I'm making you do these drawings. That time and effort should hopefully help you to continue to learn and master this material. All right. Questions on that?
I did notice on the handout that for the transitional epithelium, it's asking for the mucous membrane. Is that the same as?
Is that the only place you found it?
Well, probably not, but.
No. So I want this handout to be all inclusive of the type of information you are going to be responsible for. And as I just finished mentioning, some of the things you're going to be responsible for is going to be membranes. However, I will tell you right now, membranes are made up of epithelial tissues and connective tissues together.
Okay.
We've only talked about epithelial tissues yet. We haven't talked about connective tissues. And since we haven't talked about connective tissues, we can't put them together to membranes yet. So we will come back to that and make sense of it. And I promise we will do that. But you're right. I wanted it on the list because it is something you're responsible for, but we haven't built up to it yet. We're still building.
Okay.
All right. Great question, though. I was hoping someone would catch that. I'm glad you at least caught it on the last one because it's been on there for the past couple slides. But I'm glad someone finally caught that and mentioned it because that is important. All right. That is it for the histology that I want to cover for right now. So what, oops, no, I don't want to do that. I want to do this.
I have a quick question. So in some of the slides we saw hair shaft growing from the skin. Does it grow from between cells or does it grow from like a single cell?
So we absolutely will get to the integumentary system, but no, it is hairs are multi-celled structures that grow out of multi-celled structures, a structure called a follicle. A follicle is where we grow the hair out of. And so, yes, those are multi-celled structures, and we will indeed talk about them. But not yet. All right. Any other questions? All right, we are almost done with epithelial tissues, but not completely done with epithelial tissues because as I mentioned, the other thing we need to know about epithelial tissues is they are used to make our glands. So the last little bit we need to cover for today is to talk glands. So to do that successfully, we're going to take one last break. So let's go ahead and take we'll go 15-minute break. An hour should hopefully be enough time. So let's meet back here in 15 minutes, which is 3:27. Oops, that's not a 3. 3:27, and at 3:27, we will restart. And I'll start the recording at that point. And at that point, we will talk glands. All right. Any questions? All right, see you in 15 minutes. So the last thing we need to talk about to finish up our discussion of epithelial tissues is to talk about the fact that epithelial tissues are used to make our glands. Now, when we talk about a gland, obviously we need to define what a gland is. A gland is either a single cell or a mass of cells that is adapted for secretion. In the body, we primarily have two types of glands, endocrine glands and exocrine glands. So let's define them, all right? What do we mean by exocrine? What does exo refer to?
Out.
Yeah, outside. Anyone know what crine refers to? Close, not quite ducts, but it refers to secrete. So exocrine glands literally secrete outside of the body. Conversely, then endocrine, crine still means to secrete. So what does endo mean? Yeah, within or inside, within the body. So basically, endocrine glands secrete their substance within the body. Exocrine glands secrete outside of the body. Now, to secrete outside of the body, exocrine glands use ducts. I think I saw someone say ducts. So exocrine glands use the duct to secrete the substance out, whereas endocrine glands are ductless. I don't know if that's actually a word, but I'm going to go ahead and use it like it's a word. Basically, instead, they produce a secretion and basically release it into the humors of the body. What do I mean by the humors of the body? The funny parts? Left elbow is pretty hilarious.
Would that mean like fluids?
Yeah, exactly. It's exactly what it means. The fluids of the body. Obviously, eventually it all pretty much ends up in the blood, but it can be released into the lymph, into blood, into the interstitial fluid, and so on and so forth. And of course, once it gets into the blood, it can go anywhere in the body. And typically, when we talk about endocrine glands, what kind of substances do endocrine glands produce?
Hormones.
Hormones, exactly. Hormones. These are those chemical signals that are being produced and released throughout the body. Excellent. Exocrine glands use ducts, release the substance outside the body. Give me some examples. Give me an example of an exocrine. Well, let's go. Let's finish off endocrine first. Give me an example of an endocrine gland.
Your pituitary gland.
Yeah, there you go. Pituitary is the master endocrine gland. Excellent. Give me one more.
Would the thyroid at all be in this section or no?
Absolutely. Thyroid is an endocrine gland. Absolutely. Those are all things that produce hormones and et cetera, et cetera. Perfect. Excellent. Give me some examples of exocrine glands.
A sweat gland.
Sweat. Excellent. What else?
A sebaceous gland.
Okay, sebaceous gland. So those are the oil glands of our skin.
The pancreas or the liver.
Mammary gland. Well, pancreas is trickier. Let's talk about let's because the pancreas actually is both an endocrine and an exocrine gland. But let's talk about the liver. What does the liver produce and release?
Bile.
Bile. But where does it release that bile?
Into the bile ducts.
Okay, but where do the bile ducts feed it into?
The gallbladder.
Well, it stores it in the gallbladder. So let's say it's stored in, but where would the gallbladder release it into?
Didn't it go into the stomach and mix with food?
Not the stomach. You get the right idea, though. It does mix with food,
Small
but it mixes with food in the small intestine. Absolutely. Isn't that inside your body?
Yeah, but then you
Yeah,
it
but
out.
would the process of it be going out of the liver?
Okay, let's take an easier one then. What about your salivary gland? Does your salivary gland secrete outside of the body?
No.
No? Yes?
Yes.
Well, let's take this. I have this clip in my hand, right? If I put it on my hand, is it inside my body?
No.
No. What if I wrap my hand around it? Is it inside my body now?
No.
No.
No. It's surrounded by my body, but it's not inside. To get inside, you have to penetrate through a membrane. Your digestive system basically is a hollow tube that runs all the way from your mouth to your anus, about 30 feet long. And the entire lumen of your digestive system is actually considered to be outside the body. They give it a fancy word because of course they do. They call it the topological exterior. Right? Think about it. Again, hopefully nobody swallowed a clip like this, but there have been plenty of kids who have swallowed a penny. And when you swallow that penny, what happens to the penny when that kid swallows the penny? It enters into the digestive system, and then what happens?
It's stuck in their throat.
Oh, okay. Well, it could, right, if they're really little. But if a 10-year-old swallows a penny, what happens?
Wait for it to pop.
Yeah, pretty much you have to eventually wait, and it's going to come out the other side, right? A little cleaner or a little dirtier, depending on how you want to think of it, but it's going to come out the other side, right? And it is never going to have actually entered the body. That's different from that cheeseburger you had for breakfast, right? You had that nice big cheeseburger for breakfast with the seeds on it. It got into your digestive system. We broke that down into bits and pieces. And then those bits and pieces were absorbed across the membrane into our body. Your body has no need of currency, so that penny passed right on through, never actually entering into the body. So your salivary gland, your liver, all of the stomach acid, all of those things that are released into the alimentary canal are considered to be outside of the body. So absolutely that bile, the liver, absolutely your salivary glands, all of those are examples of things that absolutely do secrete outside your body because the digestive system's lumen is actually considered to be outside the body, the topological exterior. All right. Now, endocrine glands, we now understand, but we're not going to talk about those till we get to the endocrine system in 431. So we'll come back to this in 431. So for now, we're going to focus on our exocrine glands. Now, not surprisingly, when we identify exocrine glands, we can identify them basically three ways. Structurally, how they're made, functionally, how they work, and what they release. The what they release is the easier part, right? Salivary glands release saliva. Sweat glands release sweat, so on and so forth. So that's the easy part. So what we are going to need to work on is we're going to need to work on identifying the structural classifications and the functional classifications of our exocrine glands. And I will tell you right now, there are 8 structural classifications, and there are 3 functional classifications. Eight's harder, so let's start with that one first. Structural classifications of glands, of exocrine glands, and again, as I mentioned, there are 8 of them. The very first structural classification and the easiest structural classification is a unicellular gland. Guess how you would describe a unicellular gland?
Made up of one type of cell?
Exactly. It is a single cell that releases its content outside of the body. There you go. There are lots of examples of them. In fact, we've already seen one. Your friend and mine, the goblet cell, was a perfect example of a unicellular gland. Here again, we see it in what type of tissue is it sitting in? Identify the tissue type in the field of view.
Pseudostratified ciliated columnar epithelial.
How did you know?
Because there's cilia on top.
Yep. Nuclei kind of all over the place. And the fact that it said it on the slide probably didn't hurt much either, right? Absolutely. So again, lots of ways we were able to distinguish that. But cilia are definitely a good giveaway, but so is a label. A label's a good giveaway as well. And being the smart, sophisticated students you are, there's nothing wrong with that. Here we see an illustration of how this cell works. It makes its secretion, fills these vesicles with proteins, and that's what gives it that big round bulbous shape, is that goblet cell, because it's just chock filled with these vesicles, and then it releases the contents via exocytosis. And what was the substance that's contained inside these goblet cells again?
Mucin.
Mucin, absolutely. All right, that protein that is going to hydrate and become water. Excellent. So that is our easiest structural classification. And I'm going to cheat and go to my whiteboard now for the rest of this. We are talking about structural classifications. Stop it. And as we mentioned, there are 8 of them. And the first is unicellular, single cell. That's easy. So that means for all the rest, they are multicellular. With a multicellular exocrine glands, we're going to need rules. The first thing, remember, that we talked about is that the multicellular exocrine glands have 2 components. The first is the secretory structure. Guess what the secretory structure does? It's not a trick question. What do you think the secretory structure does?
Wouldn't it just secrete?
Yeah, it makes and releases the substance. These secretory structures, plural, come in 2 shapes. One of those is a very long, hollow, tube-like structure that we call tubular. The other is a big round ball-shaped structure that we call an acinus, being singular. I guess we'll go with cinar, we're going adjectives. Or it is also known as alveolar. But both of these are ball shape. Don't use the term ball, use either a cinar or a velar in describing them. And they are these round ball shape structures. Their job is to produce and release the contents. Now, there's one more thing I will say about these tubular. Some of these tubular are long and straight like this one is, but some of the tubular will be kind of twisted, and one could even say coiled. And in fact, that's what they're called, a coiled tubular gland. So it can be straight or it can be coiled. And then a ball shape is a ball shape. So that's one of the ways we're going to describe it. But remember, these multicellular exocrine glands also are comprised of ducts. And ducts are just conduits. I don't remember if we've used that term in this class or not, but when I say that it is a conduit, what does that term mean? Anyone know what a conduit is? I guess it's a good thing I use the term here. Go ahead.
Pathways.
Exactly. Basically, it's just a passageway. Many of you may not know what a conduit is, but many of you probably have sprinklers out in your backyard. Your sprinklers out in the backyard don't have water magically appear out of nowhere. There is a PVC pipe that carries the water to the sprinkler head. Does that PVC pipe make the water, modify the water, add anything to the water, take anything away from the water, change the water in any way? No. It's just a passageway for the water. And that's what a duct is. A duct is just a passageway for the secretion to the outside of the body. Bingo. End of story. So all multicellular exocrine glands are made up of secretory structures and ducts. So we put these together. You can have one of two secretory structures, tubular or alveolar or cinar. And we identify these glands by the number of ducts and the number of secretory structures. So let's make some rules. One secretory structure plus one duct equals a simple gland. Two or more secretory structures plus one duct is what we call a branched gland. Now, some textbooks, some locations, you will see the term simple branched. If you want to use the term simple branched, I'm fine with that, but I find it confusing. Simple is simple, branched is branched. I don't know why they put it together. Anatomists hate you. So again, if you want to use simple branched, that's fine, but you are also welcome to just use branched. Lastly, two or more secretory structures plus two or more ducts, equals a compound gland. So those are the rules, and it really is just that easy. Everybody got the rules? Because I want to erase the screen.
Yes.
All right, let's put the pieces together. I will draw the outer surface of the body. To that outer surface of the body, I will take a gland and we'll use blue for a single duct, and we will use red for a single long, narrow, tube-shaped secretory structure. How would you identify this gland that I have just drawn?
Simple gland?
Simple.
And you get partial credit for that on the exam.
Gland.
Simple tubular.
Simple tubular. Conversely, if I had a single duct with a single ball-shaped secretory structure, what would that be?
Simple alveolar.
And again, you can say a cinar or a velar, either of those would be fine. We're getting there. What if I have one duct? And I don't know if this will let me do this, so I'll have to draw it. Two long, narrow, thin secretory structures. How would we identify this gland?
Branched tubular.
Or if I had one duct with three ball shape secretory structures connected to it, what would that be?
Compound gland? No.
One duct,
No.
two or more secretory structures that are ball in shape. Branched. There you go. Branched alveolar. And again, anywhere I've said alveolar, remember, you could also say acinar because those terms are interchangeable. What if I had a gland, and now I'm going to have to draw freehand for all of this, a gland that had two or more ducts to them to go along with two or more long, narrow secretory structures. What would this be?
Compound tubular?
Compound tubular. Excellent. I now need to draw a new surface to my skin or body. Bingo. And let's move it up a little bit. Excellent. What if I had two or more ducts feeding into two or more ball-shaped secretory structures?
Compound alveolar.
Excellent. Or acinar. And there you go. That gives us our 8, right? Unicellular, simple tubular, simple alveolar, branch tubular, branch alveolar, compound tubular, compound alveolar. 8. No. Wait. That doesn't work. What are we missing?
Compound tubular.
There you go. What were to happen if we had a gland that had two or more ducts to it, and on that there were some ball-shaped secretory structures and some tube-shaped secretory structures? In that case, as you guys mentioned, this would be a compound tubulo-alveolar glands.
Can you say tubulo-acinar?
Yes. Tubulo-acinar. What you can't do is separate them into two words. It is not a tubular alveolar. You have to mash them together into one word. Tubulo-alveolar or tubulo-acinar, all one word.
Can you say that again?
What part?
The tubular part.
Okay, tubulo-alveolar or tubulo-acinar. So again, you're putting it together into one word. And I've written it here, tubulo-alveolar. It's all one word. Tubulo-alveolar, tubulo-acinar, either way, all one word.
Does that happen pretty often in our glands that we have such a big variety?
Well, if you think about it, we have lots of different secretions that we make. We make sweat. Sweat happens to be simple tubular for those. We have things like our oil that is produced from our skin. That's in a branched alveolar. And probably my favorite bodily secretion, saliva, right? As an older sibling of 3 younger sisters, I am required by law to torture them as much as possible. And so, as I'm sure many of you who either are or had older siblings know, one of the favorite things an older sibling loves to do is kneel on the chest of a loved one and dribble just the tiniest little bit of saliva out so that it almost touches their nose. And then right before it touches their nose, you slurp it back up. How are you able to do that? Because there are 2 components to saliva. Saliva is watery, and so for that, it produces a watery substance that mixes with our food, and that's where the ball-shaped secretory structures come in. But what holds it together and lets you dribble it out and bring it back is it also contains mucus, and the tubes make the mucus. So our saliva has two main components, two different secretory structures that together mix to make your saliva. So yeah, we have all sorts of different types of these throughout the body. And not only is this a perfect essay question, where you would have to, obviously you wouldn't be drawing it, but you would have to describe all of the structural classifications, but every single gland you run into in this class, from this point moving forward, not only are you going to need to know the gland, but you're going to need to know its structural classification, its functional classification, and what substance it produces. All right. Not the worst job of drawing these things. And one of the nice things about me doing it this way is I can exaggerate the tubes and I can exaggerate the ball-shaped structures. You'll notice your textbook does this as well, although not quite as well. Notice again, we can have unicellular, multicellular, either tubular or alveolar secretory structures. We talked about branch, one duct, one gland. Simple, one duct, one gland. Branched, one duct, multiple glands, compound, two or more ducts, two or more secretory structures. And here are the pictures from your textbook. Notice here is our simple tubular, and again, they call a simple branched tubular. These are their tube-shaped structures, and these are their ball-shaped structures. Notice they're not quite as differentiated as they could be, but they still show the difference between the single duct and the secretory structures. Here is the compound tubular, compound alveolar, and the compound tubular alveolar. So your book shows these as well, just the same way that I drew them as well. So 8 multicellular structural classifications, but we can't forget about that single-celled gland. So 8 total structural classifications for exocrine glands. All right, questions on that? All right, if you've survived this, then the good news is it gets way easier from here. Because while there are 8 total structural classifications, there are only 3 functional. So there it's much, much easier. 3 functional classifications. And we have some decent pictures that show this process as well. So I won't bother drawing this one. Here we see a single cell using the merocrine mode of secretion. Merocrine is by far the most common method. And if we look at this illustration, we can see some very similar processes. Here in the nucleus, we make a messenger RNA, which we send to our rough endoplasmic reticulum, which turns it into a sequence of amino acids, which sends it to the Golgi apparatus, which folds it, adds it to other subunits to make a functional protein, puts that functional protein in a vesicle, brings it to the plasma membrane, and releases those contents. What do we call that process?
Is that exocytosis?
Exactly. Basically, the merocrine mode of secretion uses exocytosis. It produces the substance, sticks it in a vesicle, and releases it via exocytosis. Now, this may seem like a silly question, but let's ask it. Is the cell damaged by this process?
Yes, slightly, not permanently.
How? How is it damaged?
Well, when endocytosis happens, it pinches off some of its plasma membrane, which then it's missing some of its structure and size.
Okay.
And then exocytosis replaces it. So I was wrong. It doesn't damage, it restores.
Okay. Yeah, I like that. I can see where you're saying where when it pinches off a little bit and brings it in, it does change the plasma membrane. So I would agree with you that both endocytosis and exocytosis can change the plasma membrane. So that is definitely true. But I wouldn't say that the cell is necessarily damaged by this process. So I would say an emphatic no, the plasma membrane is really not changed by this process at all. And so it can happily do this for a very long time. And like I said, it is by far the most common type. Here we see a single cell, what it's doing. I like this picture from your textbook because here we see that glandular component that looks like a ball shape. So an acini here, producing the vesicles, releasing the contents, and then the duct carries it up. But again, those darn artists, we always have to watch out for the darn artists and their artistic license. Notice they also put some vesicles up here in the ducts. Are there vesicles in the ducts? Do the ducts help make the secretion?
Oh.
No. So again, a little bit of artistic license we have to worry about with our artists there. Not the worst thing we've ever seen on an illustration, but it definitely does not belong. Our secretory structure makes the secretion. The duct is just the tube that carries it out. And like I said, it's the most common. Our salivary gland, our sweat gland, the exocrine part of the pancreatic gland, all of these use this merocrine mode of secretion. All right. Hopefully that one's pretty simple and pretty straightforward. Questions on that one? All right, let's look at this next method. The next method is what is known as the epicrine mode of secretion. Notice the process starts in a similar fashion. Messenger RNA, sequence of amino acids, make a functional protein, stick that functional protein into a vesicle. But notice this time the vesicle accumulates in the apical portion. And then the apical portion of the cell pinches off. So what happens with this one is that it stores up the secretion and then pinches off the apical part of the cell. Is this cell damaged by this process?
Yeah.
Yeah, this does damage the cell. Does it kill it?
No.
No.
No. So it can recover. And as it recovers, it makes more secretions, fills up, and then pinches off again. So it can recover and continue the process. Notice with this one, not only does it release secretion, but also some of the cytoplasm. So typically this produces a more organic secretion. All right, story time. Right? We just finished talking about sweat, and we know how the watery sweat that you produce on the surface of your arm when you exercise, when you work out, is produced using that merocrine mode of secretion. But there's something interesting about sweat, because when my daughter was 5, she could run around the house for days and still smell like a rose. Now that she's 13, if she just sits in her room for 3 days, right, on TikTok without showering, is that a room you want to go into anytime soon?
No.
No. Why? What's the difference?
Hormones.
Part of it is hormones, but what those hormones have done is produced a different type of sweat. We have a different type of sweat gland, and that different type of sweat gland is associated with our secondary hairs. Axillary region, pubic region, anogenital region, right? Buccal region, thoracic region, all those places that grow hair that make us know that we're sexually mature versus not sexually mature. These produce a more organic type of sweat. You've got the right idea, Amanda. These produce a more organic sweat that has a lot of warmth, a lot of moisture, and a lot of organic material that bacteria love. So that's why when you work out with that shirt, throw it in your gym bag and leave it in the back of your car for 3 days during a Sacramento summer, you open that bag and it reeks because the bacteria have been feeding off of it and producing all of that stench we associate with body odor. Clearly, these produce a different type of sweat, become active thanks to those hormones. So our anatomists called these sweat glands, these special sweat glands, apocrine glands, because they must use the apocrine mode of secretion, right? And we've known about these for a long time. Back in ancient times, there was an athlete by the name of Michael Jordan, the greatest basketball player ever to live on the surface of the planet, better than Kobe, better than LeBron, right? Better than Zion. He was truly a one-of-a-time, generational type of athlete. And back in ancient times, everyone wanted to be like Mike, right? They had shoe commercials, McDonald's, all sorts of different things with Michael Jordan. And in fact, one of the things that they did is they actually took some of the secretions from his apocrine glands and used them to make an aftershave. So that even though you may not be able to play basketball like Mike, you could smell like Mike. Now, again, we're not talking about the BO. We're not talking about what happens after the bacteria gets a hold of it. Before the bacteria gets a hold of it, it tends to have a very musky type of odor that many people find pleasing. And so, yeah, he actually had his own aftershave made from his own apocrine gland secretions. And all of that is awesome and amazing and incredibly interesting, except for one problem. And that problem is that these glands, these special sweat glands that are called apocrine glands, turns out they do not use the apocrine mode of secretion. So when we get to the skin, starting on Thursday and continuing on Tuesday next week, when we talk about the glands of the skin, we're going to learn about a gland in the skin called the apocrine gland, and it doesn't use the apocrine mode of secretion. I told you, anatomists hate you. Why they haven't changed them, I don't know. Apparently, nobody wants to put their name on these stinky glands. So it is what it is. It actually uses the merocrine mode of secretion. In fact, in humans, there are no known examples of glands that use the apocrine mode of secretion. Laura, did you have a question?
That I was going to ask that. So like lactation and all that wouldn't use it as well.
Great question. So notice I say no known. They are studying it. In fact, the mammary glands is one of the places they're looking. In the mammary glands, there's really kind of two different types of milk that is produced: the fore milk, which tends to be more watery, more carbohydrate based, and the hind milk, which tends to be a little thicker, a little bit more protein based. It is believed that some of those may use an apocrine mode of secretion, but it hasn't been for 100% determined yet. And rather than rush to it like they did with the sweat glands, they're holding off on that decision now. So again, should you take this class in 5-6 years? And I don't know why you would take this class again in 5-6 years. They may have confirmed it by then, but they haven't yet. So the picture from your textbook shows mammary glands. They'll talk about the mammary glands, but we don't know it for certain yet. So there are no known human examples, no confirmed human examples as of right now. The best example of a confirmed gland are the anal glands of dogs. When a dog meets another dog, what does he do? He smells his butt. And the reason are there these apocrine glands, these anal glands that release a secretion that pretty much tells them everything about them, what they've been eating, where they've been, what their health is. They get all this information from these organic glands releasing that organic content. So we definitely need to know that it is a type of functional classification, a way, or again, when we say functional classification, remember we could also say mode of secretion, because that's really what we're talking about, how it releases its contents. But for the apocrine glands, there are no human examples. And that brings us to our third type, holocrine. Notice once again, let's look at our picture. In this case, in our picture, we have a representation. Well, again, when you sweat heavily, most of that sweat inside there is the watery sweat produced to help regulate body temperature. And that's the one that doesn't necessarily produce the same type of organic components that the bacteria can get to. Also, if you're skiing up at the top, probably not as much bacteria because up there to be able to do it right away when you take it off, because again, there's not the warmth for it as well. All right. Notice here we have a process. What stage in the mitotic phase is being represented by this illustration?
Anaphase.
Anaphase, although notice they got their V's pointed in the wrong direction. Again, you got to love those anatomists. But notice what's happening here. Cells are dividing, cells are filling up with the substance, and then the cells burst. So we have cellular division. The cell fills with its secretion, and then it ruptures, releasing everything. Does this damage the cell?
Yeah.
Yeah, this kills the cell. But it kills the cell, and so we just make more. Right. Again, here we see this simple picture that shows this process. Here, whoops, hold on. Here we see the pretty picture from your textbook. Again, notice they've got their anaphases going in the right direction, accumulating and releasing their contents. So notice with this holocrine mode of secretion, we're producing a very thick and very viscous organic secretion. Because not only is it the secretion, but it's also all of the cytoplasm, all of the materials as well. The classic example of this are and I'll put it in parentheses here, oil glands of the skin. Someone mentioned the right term for them earlier. They are sebaceous glands, and they actually produce a substance called sebum. But that sebum is that oily substance that maintains the integrity of your skin, maintains the integrity of your hair, that we're all constantly washing off of our hands because we have to wash our hands 17 times during the course of the day. So all our hands are getting dry and cracked as a result of that. All right. This is another gland, because this is very thick, very viscous, very organic. When things like hormones cause an overproduction of this substance can actually congest the gland and actually block the duct. Because it's warm and very organic, it becomes a breeding ground for bacteria. And when it becomes that breeding ground for bacteria, it can become red and inflamed as a result of that. And what do we typically call that condition? Acne, absolutely. Acne, those pimples that form, absolutely. So that acne that forms because of the congestion of these from overproduction, typically brought on by a change in hormone levels. And so there are our three functional classifications, or again, we can use the term mode of secretion because it's all about how they release their contents. Merocrine, epocrine, holocrine. So every single gland you are going to run into from here to the end of 431, you are going to need to know its structural classification and its functional classification, as well as, of course, what it produces. All right, questions on that? Excellent. Good news is we have made it through our epithelial tissues, which means next we get to talk about connective tissues. And I think that is a good stopping point.
Do we need to print off the connective tissue handout for next class?
Yes, definitely have the connective tissue handout for next class. We will try to go over, we'll actually do the gland stuff quickly as well. We'll try to get in some more histology. Although I went over the histology for two reasons. One, because I think it's important that you know the information, but also to show you what I was looking for. Now that you have an understanding of what I am looking for, if we don't have as much time, I won't spend as much time on the connective tissues. I want to make sure we get all the lecture stuff in. Like I said, we've got 3.5 days worth of material that we're having to do in 3 days. So if we have to cut something somewhere, it'll be my leading you through that. So that's why I really wanted to take the time to do that. But so you need to have it anyway, because it's due on the 16th. But I will try to get to some of that in the next class as well. I don't have a time for the next class yet. I wanted to give, so far only I looked during the last break, and so far only 13 people have filled out that survey. There's still 27 of you here, so 26 of you here, because including me. So half of you at least still haven't done it, and some other people. Remember, that survey will be open till 8 o'clock tonight. So after 8 o'clock tonight, when I get the final numbers, because they're pretty close right now, I will decide on the time, and I will send that information out. I'll do it as a Canvas announcement, and then I will also add the lecture to the confirmed Zoom, so that if you are able to make it, you'll be able to do that Wednesday night. And then if not, then I'll be posting it onto the YouTube page, and you can just view it on Thursday at the normal class time, if that's what works for you.
Do we have certain pages in the histology book to look at? Or is it just a whole thing as a whole right now?
I don't have, so if you look in the Histology Atlas, so again, there's a Histology Atlas that comes with the bundle, but you're not required to use that one. So I haven't set pages, but what I would say is if you look in it, you'll see there's a section on epithelial tissues. You'll see there's a section on connective tissues, and those are the ones you're going to go to. And again, there are pictures of these things in your textbook. There are pictures of these things in your lab manual. If you use the professional anatomy lab, or whatever it's called, in Mastering A&P, there are resources there. There's the Yale site has some great histology. There's lots of places that you get it. So I don't care where you get your pictures from, as long as you are able to draw something that makes sense to you and helps you to study this material as you move forward. So the goal isn't for you to memorize the epithelial tissue on page 74 of the Histology Atlas. The goal is for you to understand this material. So if I go to the almighty Google and pluck some picture out of nowhere, some novel picture you've never seen before, as long as it's an obvious example, you should be able to tell me what it is, which honestly is exactly what I did on the exam. Yes, there are pictures from your textbook. Yes, there are pictures from your Histology Atlas and from your lab manual and things like that. But those are probably about a third of the histology pictures. And a lot of times when I was writing the test bank and I wanted a picture, if I needed a ciliated pseudostratified columnar epithelial tissue, I went to the almighty Google. So yes, the goal isn't to memorize picture X, Y, and Z. It's to learn the material. All right, great question. Any others? So yes, so last great question, one more great question. Yes, if whatever times I pick, if you can't come for the whole thing, even if you can just come for an hour or half an hour, feel free to come, sit in, ask questions during that time while you are able to do it. And again, I'm making this live because I think it's a better learning experience. So those that can take advantage of it, I think is worthwhile. Certainly it would be easier for me to just record it tonight and be done with it, but I don't want to do that. So I want to at least give people the opportunity, even if it's for a short period of time, to come by. So there's no pressure. No one was required to come to this alternate class time, but if you have the means or the time or the availability, please feel free to come and be part of the lecture. You guys ask great questions, and I think it's a huge, important part of this class, because I'm always of the opinion that if you have a question about something, I guarantee someone else does as well. So the people who are bold enough to raise their hand and ask that question, I think is awesome. It helps all the people who are less comfortable. And I hope the people who are less comfortable learn and see the success that other people are getting at doing and getting the information they have. Because if you're confused by something, it's not helping you to learn it. So ask that question so I can help you to learn it. So by having that there, I think it's very, very helpful. So yes, that's why I want to do that this way, is to try to still make it interactive, try to help people to understand the material and to help those that are struggling with it. So that's the way we're going to do that. Yeah, and I think that's great. I have no problem with people asking 50 questions, just because everybody else has those questions as well.
Where did you say that where we could pick the option for the?
So I show it under quizzes. There should be a survey. So if you go into the quizzes, someone who's taken it, tell me if I'm wrong, but my understanding from the instructor side, where I thought I put it was under the quizzes. So if you go under the quizzes, there should be a survey in there, and that survey in there is for the alternate class time. So is that where the people who took it, is that where you guys found it?
Yeah, I just found it. It's in quizzes.
Okay, perfect, excellent. So yeah, so find that there, and you can take the quiz there, and you should be able to do that. And so again, select all the times that do work for you. And like I said, I'll leave it open till 8, and then after 8, I'll see what the results are, and then I put an announcement on Canvas saying when it is, and I will add it to the schedule so that you guys have that as well. All right. Any other questions? All right, excellent. You guys have an excellent day, and I will see you at the next lecture. Take care.